Hello everyone, welcome to Mathematics. So for today, it will be our first video to discuss the questions from this year's SPM trial paper, and we're gonna start off with Kedah paper 1. Alright, so I went through the paper already and I realized two things. So the first thing is the difficulty of this paper. So compared to last year, I would say that this paper is slightly easier. But of course, this paper has its own complex and not so straightforward questions, right? So for this year, I did something new, which is for these kind of questions, I'll be putting this purple label, or called unique label, when we are discussing the questions later. Alright, so why I put this label is because I would say these kind of questions appear more often in the trial paper questions compared to the questions that we always do in our exercise books or in the textbook. Alright, another reason why I put this label is because we can put more focus onto these unique questions, so when SPM comes up with a similar question, we can able to answer. Alright, and the second thing I realized that is some of the questions that needs the graph, they didn't provide it, which I find it kind of weird. For example, in in questions 1 and question 4. So, but this depends on certain people. So for me myself, I am a visual learner actually. So when I want to understand a question, I need some graphs or some figures to help me understand the question, then only able to answer it well. Alright, so for this one, it might need some time to draw out the graphs first, then only can answer the questions. Right? It's a bit time consuming, but again, this depends on certain people. Alright, so without further ado, let's discuss this paper together. First question coming from integration, and this is one of the questions that I've mentioned that it should provide us a graph. So that's why here I've drawn a graph to help us visualize it better. Alright, so here we are given a curve y equals to h of x, and it has a point of -2, -37. Okay, so we don't know the exact shape of the graph. It's okay, we just randomly draw a curve here and we plot the point here. Alright, and it also gives us a line which is actually the tangent to this curve. So recall back, tangent is the line where it intersects the curve only at one point. So for here, this blue line intersects this curve at this one point only, which is -2, -37. And another thing it is given, which is the gradient function of this curve, is this value. So recall back, gradient function is the function that helps us to find the gradient at any point of this curve. So for example, if I put -2, -37 inside this gradient function, I can get the gradient of this point. Alright, so essentially this value is m. Alright, m is the gradient that I've learned before. Alright, so in part A, we need to find the value of p, which is actually part of the gradient function here. Alright, so what can we do is, since we know that m is equal to px squared plus 4, we can just create an equation first. Right? So now you can see that if we want to find the value of p, we need to find the value of x and m. Alright, so for the value of x, actually we can use the x coordinate of this red point. Alright, and for the m, okay, because this gradient function helps us to find the gradient of one point, and since that point we are using -2, -37, so we need to find the gradient of this point. So how do we find the gradient? Actually quite simple, because this point actually intersects this blue color line, right? And this blue color line has its equation, and we know that y equals to mx plus c. M is actually 16, right? 16 is the gradient of this line and this point. Alright, so what we can do is, for the m, we are going to substitute 16 inside, and for the x, we are going to substitute the x coordinate. So by rearranging a bit, then we can find the value of p, which is 3. And for part B, we need to find h of x, which is the original equation of the curve. Right? So according to the question here, the only information that we have is the gradient function. So we need to recall back another very important point of gradient function, which is it is not just m, but it is also the dy over dx. So dy over dx is when we differentiate the original equation one time, then we can get dy over dx. Okay, so meaning that dy over dx is equal to this value, and since we have the p already, so we are going to change it to 3, and then we can form this equation. Alright, so now if you want to find the original equation of the curve, we need to integrate back this thing. Okay, so to start off with integration, we are going to put this curvy line at the front and dx at the back. Okay, dx is because everything here is x. Okay, so if you want to integrate, we need to integrate the things one by one inside here. So we're going to start off with the first one. So the first one, it has an x and it has a power. So what we need to do is we just add 1 to the power and then divide with the new value of the power, which is 2 plus 1, which is 3. Okay, so here will be 3x cubed over 3. Oops, sorry, it's a bit... Okay. Alright, and for this value, it doesn't have x, so we are going to add x at the back. Right? So here will be 4x. And here there's another important thing to let students know, which is if you look at this curvy line, if you see there is no limits, meaning there is numbers here up and down, we need to add c at the back. Alright, so if you don't see numbers here, please put c at the back, which a lot of students forget. Alright, so once we simplify this thing, it will be x cubed plus 4x plus c. But can this be our final answer? The answer is no. We need to find a way to find the value of c. So one of the easiest way to do it is we can find the coordinates of the point from this curve, which is -2, -37. Because here, we can substitute the coordinates inside the values of x and also the value of y. Okay, so we are going to substitute x with -2, y with -37 to find the value of c, which is -21. And our answer or our equation would be this value. Okay, so make sure that you don't write y here, make sure you write h of x because the question requires h of x. Okay, and also another thing to take note, if you look at the answer scheme here, it's a bit different from mine. So when I look back the workings here, you can see that there's a -11 here. This -11 actually should be the y coordinate, but I'm not sure why is it different from the given y coordinate here. Okay, so that's why it is different from mine. But if we follow -37, it should be -21 as the c value. Next question coming from permutations and combinations. So for part A1, we need to prove this equation. Right, so you see that for the compared left hand side and right hand side has much more things to change here and there. So what I will do is we would start from the left hand side and then to prove the right hand side. Okay, so now you see that there is this n factorial. So let us recall back the n factorial formula, which is this. So for example, if n is 5, this means that 5 factorial would be 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3, and so on. Alright, and another thing to note for factorial is, if let's say I don't want to write so many values, let's say if I want to stop at 4, right? We can do that. It's just that we need to add a factorial at the back. So all these values we can just ignore. Okay, so this is like peeling onions, you know. If let's say this 5 factorial, I don't want the 5 here, I can just take out the 5 and then I stop at 4 and I put the factorial. Alright, so here we can actually do the same thing. We can also peel out the n from the n factorial. So why I say we need to take out the n is because we need to remove the n at the bottom. Okay, so to remove this n, why not we remove the n from the factorial and then to cross off each other, which is something like this. Okay, from the n, I take out the n and I stop at n minus 1, as you can see here. Right? If I want to stop at n minus 1, then I just put a factorial at the back. And then I can cross off the n at the denominator. So here I can cross off, then I can prove the right hand side already. Okay, which is n minus 1 factorial. And if we go to part 2, it says, hence, find the number of ways for the 6 members to sit in a round table. Okay, so we need to find the number of arrangements to place these members in the round table. So let me show you all the formulas that will be used in this chapter. Okay, so now in our current situation, we need to arrange all the members, right? So here we need to look at the all situation, okay, the all case, and here we are arranging them in a round table. So meaning this is a circular arrangement, a round arrangement. Okay, so we need to look at this column. So by looking at here, this row and this column, the formula that we need to use is this one, n factorial over n, which is also actually the formula that we have proven just now, right? N factorial divided by n is n minus 1 factorial. Alright, so if we want to find the answer for this one, our n we can substitute with 6 and we can find out the answer, which is 120. Alright, moving on to part B, we have a rowing competition, and one of the teams, they have 6 men which are under 30 years old and 5 men which are over 30 years old. Alright, so they need to form a crew where 1 will be the coxswain and 8 will be rowing. Okay, so today I realized that this word is pronounced coxswain, so you learn something new every day. Alright, so this coxswain is actually the helmsman in this diagram. Alright, I'm not sure why the label is different, but actually both of them are the same. Okay, so there will be 1 coxswain here and there will be 8 rowers. So if you see these 8 rowers, 4 will be facing to the left side and 4 will be facing to the right side. Okay, so now we need to find the number of ways to select. Alright, to select the crew by satisfying this condition, which is at least 3 players must be over 30 years old. Alright, so to solve this kind of questions, the first question that we need to ask ourselves, and it's a very important question, which is, does this question belong to a permutation question or a combination question? Alright, so we can look for the keywords in this question. So the keyword for this question is select. As we know, select doesn't involve arrangement. We only select the people to be our crew. Right? So this means that this question is actually a combination question because of the select keyword. So since this is a combination question, then we can use the table method to help us solve the question. Alright, so how to use this table method is, first thing first, we need to identify the categories. Meaning to say, we need to identify the categories which these men come from. So if you realize these men are actually split into 2 categories. So one category is they are under 30 years old, and the other category, it is over 30 years old. So these will be our 2 main categories. Alright, so for the top left part here, let us put the maximum number of men that can be chosen from, which belong to less than 30 years old. So here will be 6 people, and for the more than 30 year old category, it will be 5 people. Okay, so these 2 values will be the maximum number of people that we can choose from. Alright, the maximum number of people. And for the left side of the table, let us put the maximum number of people that we can choose from. Alright, so recall back, we only need 1 people as the coxswain and 8 rowers. Right? So 1 plus 8, 9. Okay, so now going back to our condition that we need to satisfy, which is at least 3 players over 30 years old must be in the team. Alright, so for this table, let's list out all the possibilities that can satisfy this condition. Right, so the most obvious possibility would be I choose 3 players over 30 years old. Okay, so I put a 3 here, and this would be my first situation. The second situation can be, okay, I add another extra more than 30-year-old person inside the team. So from here, 3 will become 4. Right? And then I can add on as well, and I find my third possibility. So here can be 5 people. Or if possible, you can go to 6 people as well. Alright, but here we need to double check the maximum number of people that we can choose, which is 5 only. Alright, so it cannot go beyond 5. So this 6 is not possible, so means for this situation, there will only be 3 possibilities. Okay, so once we identify all the possibilities already, then we can figure out the number of people for less than 30-year-old. Right, so this one very simple. For the first possibility, it will be 9 minus 3, which is 6. Second possibility is 9 minus 4, which is 5, and so on. Alright, so now for each possibility, then I can find out the number of combinations. Alright, so here to start out with the first possibility, it will be from the 6 people, I choose, which is C, 6 people from the 30-year-old group. Alright, then I multiply with 5 people from the 30-year-old group, and I choose 3 of them. So here will be 5C3, sorry. Okay, then I will add with the combinations from the second possibility. So same thing as well, 6 I choose 5, multiply with 5 I choose 4. Okay, then I'll add with the third possibility, which is 6 I choose 4 times 5 I choose 5. Okay, so once you put all this into your calculator, then you can get your final answer, which is 55. Alright, so this is actually one of the unique questions, and it is for part C. Alright, so before we go to part C, just a reminder that for the crew, 1 will be acting as the coxswain and 8 will be rowing. Alright, so for part C, we need to find the number of ways to arrange the 9 crews by following these 2 conditions. Okay, so before we go into the conditions, let us ask ourselves the main question for this kind of questions, which is this question a permutation question or a combination question? So since here it says arrange, which means arrangement is involved, means we need to use the permutation way for this question, right? Okay, so we're going to use NPR for these 2 questions. So for part 1, it says that there are no restrictions. Okay, so from the 11 men that we have, right, we need to choose 9 of them and we need to arrange them. Okay, so for the first part, it will be quite straightforward. It's just 11 people. I choose 9 of them to arrange. So it will be 11P9. Okay, and this would be the answer. So make sure you write it correctly. It should be 199,584,00. Alright, the second part can be quite confusing. So let me pull out the technique if we are solving permutation questions. So we can use this technique which are called boxes. So how to use these boxes way is, okay, so from this question, let me duplicate a similar view from diagram 2. Okay, so as you can see here, there are 3 kinds of boxes. So the first kind of boxes is this triangle, right? This triangle will be placing the helmsman or the coxswain here. Okay, and for the orange color boxes, here will be the people that will be placed as the right rowers. Alright, the right rowers. And the boxes which are in grey, I'll be placing the left rowers. Right, so here will be 3 kinds of boxes, and we are going to put the people according to these boxes. So why I use boxes is because it helps us to demonstrate how are we going to arrange the people lah. Okay, so let me explain this question by doing some animations here. Alright, so here in total we have 11 people. Alright, and from the 11 people, 3 of them can act as the coxswain, but they cannot row. So means that these 3 people will be fighting for this box, this triangle box. Alright, so meaning one of them can be inside here only. And it says that the others cannot act as the coxswain, but only can row. Which, as you can see, there are total 8 of them. And as you can see, the rectangle or the square boxes, here we have also have 8. So meaning everyone here can have a place here. Because 8 people, 8 boxes. Alright, so now here it also says that for those who can row, only 2 of them are able to row on the right side only. Okay, so from the 8 people, let me color 2 of them which, label the people which can only row the right side by changing them into orange. Okay, so these 2 people can only row on the right side. So how do we solve this question effectively is by looking group by group. Okay, so the first group would be the coxswain group. So as mentioned just now, 3 people will be fighting for this one box. So if you want to write it in terms of P, we can write it as 3P1. 3 people, I arrange them with this one box. Alright, the second group would be the right rowers group. Alright, because here we have a condition where these 2 people are right rowers. It cannot be left rowers. Right? So these 2 people confirm they will be placed under 2 of these 4 boxes. Right? But the issue is the right rowers, they are missing 2 people left. Okay, so to choose those 2 people, we can choose from the 6 remaining people. Because these 6 can be left rowers or it can be the right rowers. Right? So here we just need to choose 2 of them up first. Alright, so here will be a bit special. We are not using P, we are using C. Okay, again, because the right rowers, they are missing out 2 people, so we need to choose 2 people from the 6 people here. Okay, so here doesn't involve any arrangement, we are just choosing 2 people. Right, so let's say those 2 people would be these 2. Right, so now we have a total 4 people. But of course, this is number of arrangements. We need to find the number of ways to arrange these 4 people into these 4 boxes. So if you want to write it in terms of P, it will be 4P4. 4 people, I would arrange them into these 4 boxes. Alright, so C here would be the part where I choose people, and the P here would be from the chosen people, which is these 4, I arrange them. Okay, so these 2 work hand in hand together. I choose people first, then only arrange. Okay, and don't forget the last group, which is the left rowers group. So here we have another 4 people, and we are going to place them into these 4 boxes. So here we also 4 people, I will be arranging them into these 4 boxes, which is 4P4. Alright, so now once we have all the permutations and the combinations already, then we can find the number of arrangements by just multiplying all these 4 numbers. Okay, so this is the tricky part which I also missed out. So actually, if you see this arrangement, the first rower is actually the right rower. But what if the first rower can be the left rower first? So as you can see, the way number 1, right, it starts from the right rower, then left, right, left, right, left, right, left. But way number 2, it can be the left rower first. So instead of the right rower here, we start off with the left rower first. So left, right, left, right, left, right. Okay, 2 different kinds of arrangements. So since we have two ways to arrange the rowers, so does this mean we have to go through this process again? Well, actually, because the number of rowers here didn't change, so for example, we have one coxswain for each ways, and we have 4 left rowers for each way, and also 4 right rowers for each way. So there are no changes in terms of the number of people involved, so means that the number of arrangements for way number 1 will be the same as the number of arrangements for way number 2. So here we don't need to go through the same process again, we can just multiply a 2. Right? Because again, for each ways, the total number of rearrangements is the same, which is 3p1 times 4p4 times 6c2 times 4p4. Okay, so we just need to multiply a 2 and then we can find out our final answer, which is 51840. Alright, question 3 coming from probability distributions. Right, so here we have a survey and it says that 35% of the students do not have a scientific calculator. Alright, so when you're doing this survey, 3 pupils are randomly selected. Alright, and in part A it says that we need to complete a binomial probability distribution table, which is this table below, for the pupils who does not have a scientific calculator. Alright, so let us understand what is a binomial probability distribution table first. So as you can see in this table, there are 2 rows. Right, so let's focus on the first row, which is R. So R here represents the list of possibilities that can occur in this experiment. Alright, so let me give you the 2 extreme cases. So it can be from the 3 pupils that we have selected, none of them do not have a scientific calculator, right? So that's why here it will appear 0. Okay, and another extreme can be from all the 3 pupils that I have selected, 3 of them do not have a scientific calculator, right? So that's why the n here would be 3. Okay, so that's why here, if we list down the numbers from 0 to 3, there will be 4 numbers, right? So meaning 4 possibilities. Alright, so here R represents the list of possibilities. So for the second row, okay, this one is the probability. Okay, so for each of the possibility, we need to figure out the probability. Alright, so now before we solve any kind of a binomial question, we need to ask ourselves this main question. Okay, which perspective are we using to solve the questions? So what do I mean by perspective? Okay, so if you recall back the definition of binomial experiments, right? The experiments using binomial, for each experiment, they will always have 2 outcomes. So for example, left or right, up or down, heads or tails. So in our experiment, it will be, does the pupil do not have or have a scientific calculator, right? So our outcomes would be do not have or have a scientific calculator. So now, how do we select our perspective? So actually we can look at our questions, right? So for example, part A, it says that the number of pupils who do not have a scientific calculator. And for part B1, it also says that the pupils do not have a scientific calculator. So this is an indication that we can use do not have as our perspective and to solve the questions easily. Alright, so now once we have chosen our perspective, which is do not have, then we can find the probability for each of the possibility here. Okay, so by calculating the probability, we can use the formula which is given in the formula sheet, which is formula 23. Alright, so let's start off with a probability where x is equal to 0. Alright, so now we need to figure out n. So n here is the number of trials, which is actually 3. Okay, so why is it 3? So reason is because, let's say I choose the first pupil. Alright, so when I choose the first pupil, it actually is my first experiment already. And then I experiment this pupil, whether this pupil does have a scientific calculator or do not have a scientific calculator. Okay, so once I complete my first experiment, then I choose the second pupil as my second experiment or my second trial. Okay, so same thing as well, I decide whether the pupil does not have or have a scientific calculator, and followed by the third pupil, which will be my third trial or third experiment. Okay, so that's why n is 3. Okay, and then we followed by CR. So here will be C and then R will be 0. And P here will be the probability of success. So success here really depends on our perspective. Okay, so our perspective again is do not have. And the probability that the student do not have is actually 35%. Okay, so we can take this as our P, right? So we're going to put 0.35 here, and then the power it will be R, so it's 0. Q would be the probability of failure, so this one very simple to calculate. It's just 1 minus the probability of success, okay, which is also 0.65. And then for the power, it will be n minus R, which is 3 minus 0. And then you put this into calculator, then you can find out the probability. Okay, so same goes with Px equals to 1, the probability where x is equal to 1. So same thing as well, 3C 0 here, we need to change to 1. Okay, the rest of things will be, P will be the same. So the R here need to change to 1. And here the Q is the same. N here will be the same. R here will be changed to 1. Okay, and then you can find the probability as well using the calculator. So this would be the workings for x equals to 2 and x equals to 3. So in the exam, please write out all the workings. Don't skip one of them. Alright, so once you have the probabilities already, then you can fill up in this table. Alright, so let's go to part B1. So from the table, we need to find the probability where at most 2 pupils do not have a scientific calculator. Alright, so let's list out all the possibilities that satisfy this criteria. At most 2 pupils do not have. Right, so this one very simple. It's just 0, 1, and 2. Right, these 3. So if we want to find the probability, we can just add up these 3 probabilities together. Right, but there's another way in the answer scheme, okay, which is instead of adding up these 3 probabilities, what we can do is we consider all of the probabilities first, okay, which we know if we add up all of them, it's equal to 1. And then we minus off the possibility that we don't want, which is actually 3. So it can be 1, which is all the probabilities, and minus off the probability where we don't want, okay, which is 0.0429. So how can we write out this? Okay, so here it says at most 2 pupils, right? So we can write it as the probability where x is at most 2. Then it will be 1 minus this probability, right? So it will be 1 minus when probability x equals to 3, and then I'm going to substitute the probability here and find out the probability, which is 0.9571. Right? So if we go to part 2, it says that all of the pupils does have, alright, take note, yeah, have a scientific calculator. So as you can see here, this one is different from our perspective. Alright, our perspective is do not have. So to solve this question, what we need to do is to change this question to our perspective. Alright, so here we need to change it to do not have. Right, so if all of the pupils have a scientific calculator, which means none of the pupils do not have a scientific calculator, right? Because all of them have, so means none of them do not have. So if according to our table, the possibility where none of the students do not have is this one, right? 0. Okay, so our probability would be probability where x equals to 0, and this would be our answer, 0.2746. Next question coming from linear law, and this is one of the questions that I've mentioned that a graph is not provided, so no choice, we have to spend some time to draw out the graph to understand the question. even better. Alright, so here it says that there is this straight line graph. It is obtained by using the axes log base 10y and log base 10x. Okay, so let us draw out this graph and we use the axis into here. Alright, so the y-axis will be log base 10y and the x-axis will be log base 10x. Okay, and also they give us another information, which is the x-intercept is 2 and the y-intercept is 1. Alright, so if we assume that the 2 here is somewhere here and the 1 is somewhere here, then we can draw the line. It will be something like this. Okay, so now it tells us to express y in terms of x. Alright, so if we want to do this, we need to have an equation. So meaning we need to combine all of this information and to put it into an equation. But how do we form that equation? Okay, so why this question is labeled as unique is because we need to take some of the things from other chapters to be able to solve this question. So to form the equation, we need to recall back the things that we learned in Form 4 Chapter 7, Coordinate Geometry. Alright, and then we need to recall back the ways to form a line equation. Okay, so if you remember, there are 3 and one of them was the intercept form, which is this one. Okay, x over a plus y over b equals to 1. So x here is actually the x-axis, y will be the y-axis, a here is actually the x-intercept, b would be the y-intercept. Okay, so since these 4 information we already have, which is log base 10x, log base 10y, 2 and 1, then we can substitute all of the information inside this equation. Okay, so for the x and y, it will be log base 10x and log base 10y. And for the a and b here would be 2 and 1 respectively. Okay, so now we can use this equation and let's simplify it. Alright, so the first thing is let's remove the denominators first. Okay, so the way that we can do that is we multiply the entire equation with 2. Alright, so it will be something like this. So now if you see this, is it actually a logarithm equation? Alright, so to solve any kind of logarithm question, I will always recommend students to use this 3-step method to solve any kind of logarithm question. Alright, so the first step is to change the base. Alright, so base meaning the values here lah. Okay, so the 10 here and the 10 here. But as you can see, these 2 bases, they are actually the same. So actually, for the first step, we can skip. Okay, because the base of the logs are the same. Alright, so we can skip to the second step, which is to manipulate these logs to simplify them even further. Okay, so if you see the logs here, they are added together. Alright, so if you look at the laws here, you see this one? So the logs, if they are added together, basically the values of the log can be multiplied. So meaning the m and the n here, which is the values of the log, can be multiplied. But before we combine the logs, as you can see, there is this value outside of the log. So we need to find a way to remove it first. So if you look back the formulas given here, yeah, as you can see this one, the n is actually outside of the log. So this formula suggests that this n actually can be moved into the log and will be the power of the value here. Okay, so meaning this n, I move it to the power, so it will be here. So for our case, this 2 will be moved to the power of y. Alright, so it will be something like this. So the 2 will become the power here, and here will be y power of 2, or y squared. Alright, so now there's no value outside of the log, then we can multiply the values of the logs. Alright, so here will become xy squared. Alright, so now we cannot simplify even further by using these formulas already, so we need to go to the third step, which is to change the form. So this equation is actually the logarithm form. Alright, so now what we need to do is to change to the index form, which is very simple. We just push the base of the log to the other side. Okay, as you can see, a from the left becomes on the right side already. So the 10 here, we just push it to the right side. So here will be 10 square. Alright, so now you can see there is no logs already. Then we can solve the equation by expressing y in terms of x already. Okay, so move everything which is not y to the right side and remain y on the left. Okay, so for the x here, we can move it, and here will be divide by x, and the square we can move to the other side, then it will become a square root. Alright, but here there's a thing to note. If you remember, every time that we move the square to the other side, it will become a square root, and there will be two versions of the answer. One is the positive version, and one is the negative version. Okay, but why did we ignore the negative version? Right, reason is because we need to see where does this y come from. This y actually comes from here. Right? So another very important thing to note for logarithms, for the values of the log, which is y, it must be 0 or it must be a positive value. Otherwise, this will be undefined. Okay, so meaning this y, if it's negative, then it is undefined. Y'all can try out by typing in your calculator. If you type, let's say, log, and then you put a negative number, let's say -1, you will receive an error. Okay, so for the values which are in log, it must be 0 or positive. That's why here we ignored the negative version. Okay, that's why here we just remain the positive version of it. Alright, so this is why it's only one type of answer. Alright, so now for this square root, let's apply to these two values lah. Okay, so here, since there is a square, so square and square root, they can cancel off. So at the end, it will be a 10. And then this square root will be applied to the x here. So here will be square root x. And this will be our answer. Question 5, coming from logarithms. Okay, so since this is another logarithm question, so to solve any kind of logarithm question, we are going to use back the same 3-step method to solve this question. Alright, so the first step is to change the base. So if you look at the logarithms given here, alright, which is these 3, you can see that the bases are different. One is just a, and the other one is AB. Right, so there's two ways to do this. Either we change A to AB or AB to A. But what I recommend is the simpler the base, the better. Right, so this means that AB, for these two AB, why not we change it to A to simplify things. Alright, so let's change all the bases to A. So how do we do this? Right, it's very simple. So the value of the log, we are going to put upwards or the numerator, and the old base, which is the A here, as you can see in this formula, it will be put at the bottom. Alright, so let's go to here. So the value of the log is B, so we're going to put it on top, and the old base is AB, so we're going to put it at the bottom. Right, and now for the C here, if we go back to the formula, C here actually is the base that we want to change, which is A. Right, so top and bottom, we are going to put A for the base. Right, same thing as well for the second logarithm. So A would be the value of the log, so we're going to put it on top, and for the AB is the old base, so we're going to put it at the bottom. And for the base that we have chosen is A, so we are going to put the A here. Alright, so now you can see that this fraction is a bit confusing, right? Because there's like a fraction under a fraction. Okay, so what can we do is, for the fraction below, why not we move it to the top? So basically, this thing will be inverted. Okay, so means for the numerator here, it will become the denominator, and for the denominator here will become the numerator. Right? So now if we change that, you can see that it's much more cleaner and much more understandable, right? Okay, so now once we reach this step, then what we can do is to go to the second step already, because here we cannot simplify even further. We need the formulas here to help us manipulate this to simplify it even further. Alright, so now you can see that there are two values multiplied together. So just now in the previous question, we used the same law, right? Just now it was split and then we combined. So now it's the other way around. From combined, we split them. Okay, so since this is multiplied, this means that if you want to split them, we just put a positive or a plus between them. Okay, and then we're going to put the logs for each of the values. So it will be something like this. Okay, we split the a and the b using the positive or plus, and then we're gonna put logarithm for both of the values. Right, so this applies to this log as well. Okay, and this will be the result. So now you can see this, I would say this is very simplified already. So why not we substitute the values into these logs, right? So one of the information given is this one, log base AB equals to square root 5. So for all the logs that has B, which is this one, and this one, all will be changing to square root 5. Alright, but how about the others, which is the log base AA? Right, so this one we need to recall back a very important fact for logarithms. If you see that the base and the value is the same, this means that the logarithm value is 1. So this means that this log, and this log will be changed to 1. Okay, so now we have successfully changed all of the logs to become values. And now we just simplify the values here to form a simple answer. Alright, so one of the ways that we can do that is we change the denominator to be the same for both fractions. Right, so the way that we can do that is to multiply the second fraction, square root 5 for the top and the bottom. Right, so the denominator here will become square root 5. And once we multiply the square root 5 into here, it will become something like this. Right, so for example, the 1 here, I multiply with the negative and multiply with square root 5, then I can get negative square root 5. And this one will be square root 5 multiplied with negative and multiply by itself. Okay, so for square roots which multiply by itself, the square root will disappear. So that's why here it's negative 5. Okay, so now we simplify this. So basically the plus square root 5 and minus square root 5, it will cancel off each other. So on the top, it will be negative 4 only. And bottom will be square root 5. But can this be our answer? The answer is no, because the denominator is still in the square root form. So we need to find a way to remove that square root, which is to multiply itself. Again, if square roots are multiplied by itself, the square root will disappear. So what we can do here is top and bottom, we are going to multiply itself, which is the square root 5. So once you multiply square root 5, it will be something like this. Okay, as you can see, the denominator square root has disappeared. Alright, so this would be our answer. Negative 4 square root 5 over 5. Alright, so there's another thing to note, which is, well, how about the third step? This one, to change the form. Right, so this step actually only applies for equations. But as you can see here, this one, we are only simplifying a value, not a equation. So that's why it's okay to skip this step. Alright, because this question is not telling us to form an equation. Alright, question 6. So this is another tricky question and it comes from trigonometric functions. Alright, so let's go through this question slowly. Alright, so here we have a unit circle. So what does unit circle means is the radius of this circle is 1. Okay, radius of the circle is 1. Alright, and from this diagram, it tells us to prove this formula. Right, so this formula you will see is very familiar, right? So actually it's one of the formulas given in the formula sheet. Okay, so instead of using it, now it tells us to prove it. Okay, so I know proving can be a bit difficult, but let us go through how do we prove this formula. Right, so let's go back to when we first started learning sine, cos and tan. Right, how do we get sine, cos and tan in the first place? Where does it come from? Right, it actually comes from the right angled triangles, right? Okay, so let me draw out a right angled triangle here, and let's say our angle is this one. Okay, the angle is here. So let us recall back. If we want to find the sine, how do we do it? Right, if you remember, sine is opposite divided by the hypotenuse. Right, so sine will be O divided by H. And for cos, how do we find it? So we can use the adjacent from this triangle and divide with the hypotenuse, right? So here will be A divided by H. So everything comes from the right angle triangle. So coming back to our question here, in this diagram, why not we draw that right angle triangle as well? Okay, so it can be something like this. Right, so this is our right angle triangle, and let's find all the lengths of this triangle. Okay, so for this one, the adjacent, alright, it follows the y-axis. So since it follows the y-axis, so why not we follow the y-coordinate? Alright, so here would be K. And the next line will be the opposite line, and if you want to find the length, it depends on the x-axis, right? So we are going to look at the x-coordinate, alright? So here it's negative h, so why not we put the length as negative h? So you will ask, why we need to include the negative? Shouldn't it be positive because it's a length? Right, so if remember, sine, cos and tan are actually very sensitive with negative. And there's one thing that we have learned, which is the ASTC method, right? So quadrant 1, quadrant 2, quadrant 3, quadrant 4. So let's say if we want to find the cos sine value in quadrant 2, we say that it is negative. Only sine is positive. Okay, so this sine, cos and tan, depending on which quadrant, they are very sensitive with positive and negative, right? So that's why we remain the negative here. Okay, so this is for the opposite line, and one more line is the hypotenuse. So hypotenuse is actually the radius of the circle, and just now we have mentioned that this is a unit circle, which means that the radius here is 1. Okay, so we have found all our lengths of the right angle triangle. So what's next? Okay, so now since they are telling us to prove this formula, which is an equation, we need to form an equation first. But what equation involves right angle triangles? Okay, let's think back. Right, so one of the formulas that depends on the right angle triangle is the Pythagoras theorem, right? So we can use these three values and to form the Pythagoras theorem, which is this, right? We square the sides of the triangle, add them up together, which is negative h squared plus k squared will be equal to the hypotenuse squared, which is 1 squared. Alright, so now we have this equation already. How do we transform these things to have sine beta and cos beta inside? Alright, so why not we first find out the values of sine beta and cos beta first? Right? Maybe, if with luck, negative h is sine beta, maybe k is cos beta. So let's find out the values of sine beta and cos beta first by using this triangle. Okay, so let's recall back, sine beta is O divided by h. So here will be negative h divided by 1. So this is negative h. For cos beta, it will be adjacent, which is k, divided by the hypotenuse, which is 1, which the value is k. So now, can you see the similarity? Negative h here, we can substitute it with sin beta. K, we can substitute it with cos beta. Alright, so we put the square inside and you can see that we have proven the formula. Right, so let me recap what did we do in part A. Yeah? So the first thing is, how does sine and cos and tan come from? Okay, that's the first question we need to ask ourselves. It comes from the right angle triangle. Right, so that's why we draw this right angle triangle and we figure out the lengths of all three sides of the triangle. Okay, then the second step is, from the right angle triangle, we try to form an equation, which is using the Pythagoras theorem. Right, then the third step, we need to find out the value of the trigo functions, which is sin beta and cos beta. Okay, and then the last step, which is to combine the information that we have and the equation that we have to substitute the trigo functions and to get our formula. And for part B, it says, hence, using the formula here, we need to see whether this equation has solutions or not. Alright, so for this equation, let us simplify it first. Okay, and since it tells us to use this formula, so what it matches here is the sine square x, right? So why not we change this sine square x by using this formula? Okay, so this formula, we can use it by moving this cos square beta to the other side first. Okay, so here will be negative cos square beta. Right, so since this question using x, so we cannot use beta, we need to change it to x. Alright, so this top part, it will become 1 minus cos square x. Alright, and then for the denominator here, I move it to the other side by multiplying 2, so it will be something like this. Alright, and then I move everything from the right side to the left. Okay, to combine everything. Okay, so now you can see that this is actually a quadratic equation. Okay, how do I see it? So basically, you can treat the cos x as x. Okay, so if you treat this cos x as x, here will become x squared, and this one will become x. So it will be something like negative x squared, negative x, negative 1 equals to 0. Right? This is a quadratic equation because there's a square here. Okay, so if you want to simplify this thing, why not we change the value of x squared to be positive first? Alright, so we just multiply negative for all of the values here. So all the values, since they are negative, all will change to positive. Okay, so now the quadratic equation will be something like x squared plus x plus 1. So since this is a quadratic equation, so we can use the calculator to factorize to find the two answers of x. Okay, but if you type in the calculator, you will notice that there's only one answer, meaning the two answers that we are expecting, both of them are the same value. Okay, so here it's negative 1. Alright, so here we get that cos x equals to negative 1. So now, going back to our question, it says we need to see whether this equation has solutions or not. So since we already found cos x is negative 1, so why not we substitute this negative 1 inside this fraction? Okay, but if we do so, you will realize that the denominator has become 0. As we know, if fractions have 0 as the denominator, there is no solutions, right? So here we can put a very brief conclusion, which is, since the denominator is 0, there are no solutions, right? And this would be our answer. Alright, another unique question coming from quadratic functions. Alright, so here we have a quadratic equation, which is this one, and it says that it has no real roots. Alright, please take note here. It has no real roots, and the c here, it says that it is a positive integer. meaning it cannot be a decimal, it cannot be a fraction, it must be a whole number. Okay, so whole number meaning 3, 4, 5, and so on. Not 5.5, 5 over 2, alright? So for part A, it says that C1 and C2 are the two smallest values. We need to state the positive values of C1 and C2. Alright, so let's go back to the clue here. No real roots. So if we see no real roots, what can we think of? Alright, we can think of the discriminant. Remember this one? B squared negative 4ac, which is called the discriminant. There are three kinds of cases: greater than 0, equal to 0, or less than 0. Right? So which one does no real roots belong to? Okay, I give you 5 seconds to think which one should it belong to. And the answer is this one, b squared negative 4ac less than 0. No real roots meaning the curve does not intersect the x-axis. Okay, but you can see the other two, it intersects. That's why there are roots. Roots meaning answers. Okay, so no real roots meaning no answers. No intersection, no answers. Alright, so let's use this information, b squared negative 4ac less than 0, to find the values of c. Okay, so the b here would be negative 4, alright, and the a here would be 3, c would be c lah, alright. So once we simplify this, it will be something like this. Okay, and we move everything which is not c to the right side. Okay, so the 16 here, we can move it to the right side, so here would become negative 16. And this negative, we can also move it to the right side. So here, take note, yeah, a lot of students will make this mistake, which is the negative, when they move it to the right side, especially for inequalities, they forget to change the sign. Alright, so for any negative which is moved to the right side, we need to change the sign. Okay, so from less than, we'll change to greater than. Alright, so now the 12, we can safely move it to the other side, and we know that c is greater than 4 over 3. Alright, so now going back to here, it says that c1 and c2 are the two smallest values, and we also know that the c is an integer. Okay, so here, since it is, the c must be greater than 4 over 3, so the smallest integer that we can think of is, okay, so since 4 over 3 is 1.333, so meaning the smallest integer will be 2, right? And the next integer will be 3. Okay, so this will be the two smallest integers if according to this condition. Because c must be greater than 1.333, so it cannot be 1, so it will be 2 and 3. For the next part, it says that, hence, if c is the difference between the c1 and the c2 from our previous part, which is 2 and 3, we need to figure out the type of root using the same equation but with the value of c. Okay, so let us find the value of c first. Alright, so let me change the working here a bit. It shouldn't write like this. It should be c would be equal to c2 minus c1, which is 3 minus 2, which is 1. Okay, and since we are finding the type of root again, so this type of root depends on the discriminant. So let us use back the discriminant to find out the type of root. Okay, so if according to part A, we've done that as well, so we can just use this one. It's just that the value of c, we substitute with 1. Okay, everything stays the same except for c, we change to 1, and we find out the value, it is positive 4, so meaning it is greater than 0. And if greater than 0 means that the type of root would be 2 real and distinct roots. Next question coming from differentiation, and this is one of the unique questions. Alright, so here we have a situation and we have this person named Cecilia. So Cecilia has an aim which is from point P, she wants to reach point C in the shortest time possible. Right? So for her to do so, she needs to go through two types of transportation. Right? So the first type is she needs to kayak from point P to point B. Okay, as you can see here, from point P, and he needs to travel through here to reach point B. And then the second way of traveling is she needs to walk from B to C. Right? So from B to C, she walks. Okay, so this is the route that she needs to go through, and in the question it also gives us the speed of when she's kayaking and when she's walking, right? So kayaking is 2 km per hour and walking is 4 km per hour. So now the question tells us to show that the time taken by her is this equation, right? So we need to prove this equation. Okay, so now you can see that all the information given, right? The time, the speed, and also in this diagram, the distance. These three things actually are related through one formula, right? Which we have learned before, which is distance divided by time equals to speed. Alright, so if you want to find the time, then we need to figure out the distance and the speed for these two types of transportation, which is kayaking and walking. Alright, so let's start off with kayaking and let's find the distance to kayak. Okay, so again, the distance to kayak would be from P to B. So as you can see, PB is actually part of this triangle, but what kind of triangle is this? So we can look at this sentence. As you can see, PA and AC are perpendicular, which means that line PA and line AC are 90 degrees between each other. Alright, which makes this triangle a right angle triangle. And if we want to find any length in the right angle triangle, we can use the Pythagoras theorem. Alright, so if you want to find the length of the hypotenuse, what we need to do is to square the length of both sides of the triangle, which is 5 squared and x squared, add them up together, will be equal to hypotenuse squared, right? Which is PB squared. Okay, so we need to find the value of 5 squared, which is 25, and we are going to move the square to the other side, right? So it will be square root. So as we mentioned in the previous questions also, when we move square to the other side, we need to consider two versions of the answer. One is the positive version and one is the negative version. But why do we only consider the positive version here? Right, reason is because we are finding PB, and PB is actually the length or the distance. Right, so length and distances, they must be positive. Right, that's why we ignore the negative version, because there will be no such thing as negative length or negative distance. Right, there will only be the positive distance. So we are just going to consider the positive version only. Okay, and this would be our distance. So now we have found the distance, and the question gives us the speed of kayaking already. So we can use this formula to find the time taken to kayak. Alright, and I'm going to denote this as TK. Alright, so substitute the information that we have, and if you want to find TK, we just switch the places between 2 and TK to get the time taken. Alright, so this is for kayaking. How about for walking? Right, for walking, same thing as well. We are going to find the distance to walk first. So going back to this diagram, the distance to walk will be from B to C. So as you can see given here, the whole line is 6 km, and one part of this whole line, which is AB, is x. Okay, so if you want to find the other part of the line, it will be very straightforward, 6 minus x. Okay, and since we have the distance and the speed already, then we use the formula again to find the time taken to walk. Alright, so for distance, I'm going to substitute 6 minus x, and for the speed, we'll substitute 4. And then I switch the places between TW and 4. TW will be representing time taken to walk. Alright, so TW and 4 switch places, then we can get the time taken to walk. Right, so now we have the time taken for the two methods of traveling. So to find the total time taken, very simple, we are just going to add them up together. Alright, so it will be something like this, but as you can see here, the equation that we need to prove only has one fraction. Here we have two, so no choice, we need to combine them. Okay, so to combine them, we need to make sure it has the same denominator, and if you look at here, the denominator here is 4. So what we need to do is very simple. For the first fraction, we multiply 2 at the top and the bottom. Alright, so once we multiply, it will be something like this, right? 2 will be multiplied and 2 will appear here, and the denominator here will be 2 times 2, 4. Right, same as here, so it will be combined together. Right, so another thing to take note is make sure the entire thing is exactly the same as what the question wants. Right, so as you can see here, the x squared plus 25 here, it's the other way around. Right, so please do not write this. Follow the equation, which is 25 plus x squared. For the next part, it says that using the tangent sketching method, prove that the time taken by Cecilia, which is this equation, is the shortest time. Alright, so what is the tangent sketching method? So this one actually helps us to prove whether a point is the minimum point or the maximum point. So if you recall back this chapter, there is also another way to do this, to prove whether the point is a minimum or maximum point, which is to double differentiate the original equation, or is d squared y over dx squared, right? Which is this one, if you remember. So last time we have learned that if it's greater than 0, then we have a minimum point. If it is lesser than 0, then it is a maximum point. So tangent sketching method is just another way to prove whether the point is minimum or maximum. But tangent sketching method requires this table. Right? So let's understand this table row by row first. Okay, so x is just x, alright, the x value from this equation. Okay, dt over dx. So dt over dx, also known as the m, which we have learned in question 1, right? So this one, dt over dx, is the gradient. So this means from point x, what is the gradient? Okay, so this row would be values. Okay, this row would be values. Right, the next row is the sign of the gradient. So sign of gradient, there's only 3 answers. Either it's positive, 0, or negative, according to the row above. Alright, and the sketch of the tangent. So sketch of tangent depends on this row. If it's positive, means that the tangent would be going up. Right, because it's a positive gradient. That's why the line goes up. For 0, it will be maintained, so meaning a straight line. Sorry, a horizontal straight line. And for negative, it will be going down. The line will be going down. Alright, so with these 3 shape of the lines, then we can form the graph. So the graph can be only 2 answers. Either it's a smiley face or a sad face, according to the sketch of the tangent here. Right, so now we understand row by row already, but how do we start off? By using this table. Alright, so there's one very important thing that we need to know, which is the center of this table would be putting in the information of the minimum or the maximum point. Right, so to start off, let's find out the x coordinate of the minimum or maximum point. Right, but how do we do that? So there's another very crucial thing about minimum or maximum point, which is the gradient, or dy over dx is equal to 0, right? Because if we draw a curve and let's say the point is here, the minimum the minimum point. If we draw the gradient, it's actually a straight line, right? Straight line, the gradient is 0. That's why dy over dx is 0. Okay, so what we need to do now is to find out dy over dx first, or meaning we need to differentiate this equation. Okay, so for this very complex fraction, how are we going to differentiate this? Okay, so this case actually we are lucky because in the denominator there's only one value. So my suggestion is we divide the value of 4 for each of the values on top. Okay, which is this 2 square root 25 plus x squared, 6 and negative x. Right, so once you divide 4 for each of the values, it would be something like this. Alright, 2 over 4, I simplify, it will be 1 over 2. The square root, I change to 1 over 2 here. 6 will be divided by 4, simplify, it will be 3 over 2. And the x here, I just divide by 4, so it will be negative 1 over 4x. Alright, so now you can clearly see that there are 3 things. Right, if we separate it using the plus and the minus, so here will be 1, 2, and 3. We are going to differentiate these 3 things. Alright, so when we differentiate this equation, it will be dt over dx because everything here is x. That's why we put x at the bottom. Okay, so how to differentiate the first one? So the first thing is we are going to copy the power here and we are going to move it to the front. Right, so here will be 1 over 2 times 1 over 2. It will be 1 over 4. Okay, and for this part, because there's an x inside this bracket, so for the power, we need to do something. Right, for this power, we are going to minus 1. Okay, so now you can see the power here, it will become negative 1 over 2. Right, for the next step, a lot of students forget, which is because this bracket has a x inside, we need to differentiate the things inside the bracket. Okay, differentiate the things inside the bracket because this bracket has x. Alright, so this 25 when we differentiate, because it's a value, hence it is 0. For x squared, we are going to do the same thing for this one. Alright, we are going to copy the power to the front, so it will be 2x, and we are going to minus 1 to the power, which is 1, so which is x lah. Okay, so here we are going to multiply 2x. Alright, 2x. Okay, so this will be the first item that we need to differentiate. So now going to the second one. Second one here is just a value, so again, when we differentiate a value, it's 0, so we can just skip this one. And for 3, so since this is only x, when we differentiate, this x will disappear because the power itself will minus 1. Alright, originally it was 1, if I minus 1, it will be 0 and x will disappear. So it will be left with the value, which is negative 1 over 4. Okay, so now, coming back here, we have already found the dy over dx or dt over dx. So now we need to substitute this with 0 to find out the minimum or maximum point. Okay, so now in this equation, let us find the value of x, and we are going to manipulate this equation here and there lah. Alright, so to simplify this thing, what I can do is for the negative 1 over 4, I'm going to move it to the left side first. Alright, and then for this part, okay, so imagine we have this thing, 6, negative 3. So if you want to change it to the fraction, it will become 1 over 6. The 6 will go to the bottom and the 3 will stick with 6, right? So the 3 will be also at the bottom. So imagine this 6 is 25 plus x squared. It will move to the bottom. Alright, it will be something like this. And the power here, 1 over 2, it will also move together. But here, I don't want to write 1 over 2. I want to change it to the square root format. Okay, so that's why there's a square root here at the denominator. And for the 2x, I'm going to put it on top. That's why the numerator is 2x. Okay, so now the 1 over 4 here, let me move it to the other side. So since we are dividing the same value, so here eventually it will be 1. And since this is 1, I can also multiply, or move this square root to the other side. And it will be something like this. Alright, and then I will be moving the square root to the other side. So moving the square root, it will square on the right side, right? So here will become this. And once we simplify here and there, make the x as the subject, or x remain on the left, everything move to the right side. So it will be something like this. So x, we have two kinds of values, 2.887 or negative 2.887. Again, why we have two versions of answers is because when the square we move to the other side, we need to consider two versions of the answer. Alright, plus and minus. But which one should we use? Because there is only one box for the x coordinate of the minimum or maximum point. Right, so let's go back to the previous part and to figure out what is x. Alright, as you can see here, x is actually the distance from A to B, which means x must be positive, right? It cannot be a negative distance, it must be a positive distance. That's why for x, we are going to use the positive version of the answer. Alright, so let's go back. Alright, so we are going to reject the negative version, and the x value of the minimum or maximum point will be 2.887. Alright, so let us fill up all the information that we have for the minimum or maximum point. Okay, so the second thing is the gradient. So as we know, minimum or maximum points gradient is 0. So we are going to put 0 here. And since this is 0, then the sign for the gradient is 0 as well. Right? So since the gradient is 0, then the shape of the tangent is a straight line, a horizontal straight line. Okay, so now once we have the x value, we can actually fill up the x values for the left side and the right side. Okay, so for the left side, you can put any kind of value which is less than the x value here. Alright, so let's say it is 2. And for the right side, we can choose any kind of value which is more than 2.887. So let's say 3. Okay, the easiest way is to choose the integers which are very close to the 2.887. Alright, so now the second thing is, how do we find the dt over dx? Okay, for this one, we need to go back to our working here, and we are going to look at this equation, the dt dx equation. So if you want to find the gradient, basically is the 2 and the 3, we are going to substitute it back to this equation to find out the answer, the gradient. Alright, so how do we do this? Let me demonstrate by opening up the calculator. Alright, so I have plugged the equation into my calculator already. So now what is missing is the x. Okay, so instead I plug in the x values that I want, which is 2 and 3, right? There's another way to do this that I think I can share to y'all. Alright, so if you notice in your calculator, okay, so it's not just this type of calculator. For any type of calculators, there will be A, B, C, D, E, F, X, Y, M here. Okay, actually we can use these symbols to help us input the x value that we want. Right? So how do we put x inside? So very simple. Let's press alpha, and then let's press this button here. Right? As you can see here, there's the x. So we need to call out this x, and it will be appearing here. And we also need to add another x after this 2. Right? So again, alpha, and then this one. Okay, so now how do we plug in the x value? Right, so here you can choose, you can press this button, which is calculate, and it will ask you what is the value of x. Okay, so let us put 2, and we are going to press enter. Right, so now you can see that the value has appeared out, negative 0.064. And then if we want to switch to 3, very easy. We just press calculate button again. We press 3 and then the value will come up. Right, so this one is quite small. That's why there's a times 10 negative over 3 here. So what we can do is press shift, press the ENG here. Okay, let me try again. Alright, so it will be 0.00724 blah blah blah. Right, so let's get back to here and to plug in the values that we have gotten. Alright, so negative 0.064 and 0.007. So now let's determine the signs for each of the values here. So this is a negative value, so here will be negative sign. This is a positive value, so it will be a positive sign. And since this is a negative value, the sketch of the tangent, it will be a downward line, right? And since this is a positive, so it will be an upward line. So when you combine the sketch of these 3 lines, you can able to know it's either a smiley face or a sad face. So in this case, it's a smiley face. Alright, so smiley face, what does this mean? Is this a minimum point or a maximum point? Alright, so again, because it's a smiley face, this is the minimum point, hence this is a minimum point. And we have proven that this equation provides the shortest time for Cecilia. Next question coming from system of equations, and here we have 3 equations and each of them have the same unknowns, which is x, y, and z. So here they are actually the simultaneous equations, and the question tells us to either use the method of substitution or the elimination method to solve. Right, so for my opinion, I would say for this kind of situation, elimination would be the best to solve. Right, so elimination works best for questions where we need to solve 3 unknowns, and for all of the equations, they are all linear. So linear meaning the unknowns here, they are separated by either negative or positive, and x, y, z don't have squares or cubes and so on. Okay, so as you can see, all of them are linear. So substitution works best for situations where there are non-linear equations. So let me give you an example. Let's say we have 2 equations. So one of the equations is x plus y equals to 3. So this is a linear equation. But for non-linear equation, it would be something like this. Let's say x squared y equals to 4. Right? As you can see, the unknowns are multiplied together and then the x has a square. So this is actually a non-linear equation. And if we see situations like this, then substitution would be the best way to solve. Right? Because for these kind of situations, elimination cannot help to solve, only substitution. Okay, so that's why substitution works best for these non-linear equations. For elimination, it's best for those situations that need to solve 3 unknowns and all of the equations are linear. Okay, so for using the elimination method, later I will show you the 5-step method for that. Okay, but before we start, we need to rearrange the equations a bit. So as you can see, these 2 equations, it start off with x, then y, then z. But the last equation didn't. So we need to rearrange this equation a bit to make sure that the x is in front. It's a 6x here. Then in the middle will be negative 4y. And then followed by 3z. Okay. And another thing, before we go into the steps, so we need to understand the method of elimination first. Alright, so elimination, the aim is actually to remove the unknowns one by one until we have left with one unknown, and then we find the answer or the value of that unknown. So that's why for the first step, we are going to choose the first unknown that we are going to eliminate. So for this case, I'll be choosing y. Okay, but why is it the unknown y? Because if you look at all of the values here, right, only this value has the value of 1. That's why I choose y. The reason is because later in step 2, when we are manipulating these equations, we just need to manipulate one of them, and then we can easily eliminate the unknown already. Okay, so let me show you. So step 2 is actually to choose two equations and to make sure they have the similar values. Right, so let's say I choose the first two equations, okay, and if I want to make sure the value of y have the same values, meaning that for the second equation, I need to multiply 3. Right? So multiply 3 here will become negative 3y. Right? And also the entire equation, we need to multiply 3 as well. So imagine, right, if I didn't choose y, let's say I choose another unknown, let's say it's x. Okay, so if I use if step 1 I choose x and step 2 I choose two equations, make sure they are similar values. So let's say the two equations is these two. So means if I want to make sure it is the same value, then for the first equation I need to multiply 5, then the second equation I need to multiply 4. As you can see, if you compare these two ways, this one and this one, which one is easier? Of course it's this one, right? Because you only need to manipulate one equation only. You don't have to manipulate two equations. Okay, so that's why I choose the unknown that has the value 1. Okay, that's why, which is y. Okay, so coming back to here. So step 2, we have chosen two equations already and make sure they have the similar values. Then now we can go to step number 3, which is to either add or minus these two equations to eliminate the y. So meaning, once we add or minus, this part will become 0. Alright, 0. But how do we do that? Okay, so let's trial and error. Let's say we start off with plus. Okay, so negative 3y plus negative 3y, which is actually negative 6y. So did we eliminate it? Actually no, because the y is still here. Right? So it could not be adding already. So it will be the other way, which is minus. Right? So imagine here, negative 3y, negative 3y. So it will be negative 3y plus 3y, right? Because negative, positive. Sorry, where's my arrow? Negative, positive. Right? So adding up together, it will be 0. That's why we need to minus the entire equation. Okay, so minus the entire equation meaning, for the 4 here, I minus with 15. 2, I minus with 15. Minus 5, I minus with 21. And you can see the answers would be here. Okay, so here we have one equation that the value of y is being eliminated already. Alright, but since here there are two unknowns, we need two equations to solve equations that have two unknowns. Right? So no choice, we need to repeat step 2 and step 3 to find another equation. Okay, so here for the second round, we are going to choose the second equation and the third equation, and we make sure that the y values are similar. So again, we just need to manipulate one of the equations only, which is this one. Okay, because here it's 4, so I need to multiply the entire equation here with 4. So now, same thing as well, step 3, add or minus to eliminate the y. So as you can see, these two have the same signs, which is similar to the one we did just now. So we just need to minus the entire equation. Right? So same method as well, minus the values one by one, and you will get this equation. So now we have successfully removed the first unknown, which is y. So now we go another step further, which is to remove the second unknown. Right, so if you look at here, there are no values which have 1. So either we eliminate x or z, the steps will be almost the same. Right, so let's say here we eliminate x. Right, so for the fourth step is to actually repeat steps 2 and step 3 to eliminate x. Alright, so step 2, choose two equations, which is these two. Alright, ensure they have the similar values. So for the value of x here, we need to make sure it's similar. But as you can see, there is one is 11 and one is 14. It will be hard if we just manipulate one equation only. So here we need to manipulate both, and the fastest way to do it is to cross multiply their values. So meaning, for the first equation, I'm going to multiply using the x value of the second equation, and the second equation here, I'm going to use the x value of the first equation to multiply. Okay, so entire equation here will multiply 14, the entire equation here will multiply 11. And as you can see, the value of x is the same, 154. Right? For the signs, you don't need to bother first, you just focus on the values. Because later on, in step 3, we are going to add or minus it. So eventually, this would be eliminated. Okay, it's just that we need to either choose add or minus. Right, so just now, as you can see, if it has the same sign, then we minus. But now, if you see the value of x, they have different signs. One is negative and one is positive. So for this case, we add, right? Because they have different signs, that's why we add. Previously, it was same signs, that's why we minus. Right? So once we add these two equations, it will be something like this. So negative 182 plus 187, it will be 5 here, and negative 364 plus 209, it will be negative 155. So now, as you can see, the x value has been eliminated. So now, we have achieved the eliminations purpose, which is we remove or eliminate the unknowns one by one, which is the x and the y. And then we have left with one unknown, which is z. And then we have found the answer of the unknown, which by moving 5 to the other side, and then we can get it, which is negative 31. Alright, so we have not done yet because we just found the value of z. We still have to find the value of x and y, okay, which is the fifth step. We are going to substitute it back, the value of z, back to these equations to find x and y. Okay, so let's say for this z value, I substitute into this second equation. So I just substitute the value of z to be negative 31. I manipulate here and there to find the x value, which is 39. Okay, then now I need to find the value of y. So let's say I substitute the values that I've gotten into this second equation. So x will become 39, z become negative 31, manipulate here and there, then I can get the value of y, which is 33. Okay, so once you have all these workings, I would recommend students to write out a final answer, right? So here will be x equals to 39, y equals to 33, and z equals to negative 31. Question 10 coming from coordinate geometry. So here we have this diagram, and let's look at some of the additional details given here. Right, so here it says that there are two parallel lines, AC and ED. Okay, so let me label these two lines as parallel lines here in this diagram. Alright, and also it says there is this point P. So this point P doesn't appear here, but it says that this point P exists in a way that it is always equidistant from point E and D. Okay, so if you don't really understand what is equidistance, you can always look at the BM version, jaraknya sentiasa sama, which means that this point P has an equal distance to E and to D. Okay, so one of the examples of point P can be the midpoint between these 2 points, right? Which is somewhere here. Right, as you can see, the distance to E and to D is the same. Okay, it's the same. So another way can be, I choose any points which is between the two lines, DC and EA. Okay, because we need to to choose the points which are in the middle of the two lines. So it can be somewhere here also, middle between these two lines. Alright, so there will be multiple points of P that can satisfy this condition. So now in part A, we need to find the equation of locus. Right, so let's recall back what is equation of locus. So this equation of locus is the line that is joined by the points that satisfy a condition. So just now our condition is this, right? Equidistance from point E and D. And we already found 2 points which satisfy the condition. So if we join these 2 points, right? As you can see, is actually this dotted line, right? Meaning in any point of this line, it will satisfy this condition. And this line is actually our equation of locus. Okay, so now we need to find the equation of this line. But how do we do that? So if you recall back, equation of locus, there are 2 formulas, right? And it depends on how many fixed points do we have. So in this example, we have 2 points, right? E and D. So we are going to use this formula, right? But as you can see, this formula, I would say it's a bit confusing and I don't recommend students to memorize it. I want students to understand it so you can apply it in anywhere when you want to use. Okay, so let's understand this formula first. So let me remove the line here, okay, between the 2 fractions here, and this equal I also remove. So why I do this is because I want you all to see there are actually 2 equations here. Okay, so what does these 2 equations represent? So the first one, which is on top, is actually a distance formula, right? Why we are using distance formulas is because the condition is equidistance from point E to point D. It involves distance, right? The distance from P to E and P to D is the same. So distance is our condition. That's why here there's this distance formula. Alright, so this first distance formula will be representing the distance from P to the first fixed point. So let's say it's E. Okay, and then the second formula here would be the distance from point P to the second fixed point. Let's say it's D. Okay, so here we need to satisfy these 2 conditions: equal distance to E and to D. So now we have these 2 equations. How are we going to combine them? So one of the ways to do it is we are going to divide them between each other. But a question you may be asking is, why these 2 formulas cannot be added or minus or multiply, but why must it be divided? Right, reason is because when we divide, we are finding the ratio. Alright, so for example, the left hand side, right? The first distance formula, again, it describes the distance from P to the first fixed point, which is E, right? And then the second distance formula, it focuses on finding the distance from P to D, right? So essentially, we are finding the ratio of PE over PD, right? Same thing as the right hand side as well, but this one is the actual distance. So M here is the actual distance from P to E, and N is the actual distance from P to D. Okay, so essentially we are using 2 different ways. One is using the formula, one is using the actual distance. We find the ratio of PE and PD, and since these 2 things are the same, so we equal them together to find out the line equation. Alright, so let's put all of our information into the formula here. Right, so the things in red, it would be the coordinates of the fixed point, which is 2, 3, and 6, 9. But how about M and N? Right, because the only information that we have is it is equidistance. So this means actually we can insert any value. It's just that M and N must be the same because they have the same distance, right? So to choose any value to make our life even easier, we just choose the most simplest value, which is 1. Okay, so now let's start off with finding the distance using the distance formula here. Right, so the distance from P to E. So the x coordinate of P is x, the x-coordinate of E, or the first fixed point, is 2, so we are going to minus them together, and then we square it, and then followed by adding up the y-coordinate of point P and the y-coordinate of the first fixed point, which is 3. Okay, and then we square root, and on the right side, we put 1. Okay, same goes to point D as well. Okay, so now we have this formula ready, then here is just manipulation, right? So the first thing first, let's remove the square roots, right? So the entire equation here, left side and right side, let me square it. Okay, so the square will apply to both numerator and denominator, so the square roots here would cross off. Okay, then on the right side, because 1 divided by 1 is 1, and 1 squared is also 1, so right side would always be 1. Okay, so since right side is 1, why not we move the denominator to the other side? So we will get something like this. Okay, and then for each of the bracket here, let's expand them out, right? So means cross multiply lah. So cross multiply, you will get the result something like this, and for this one will be this one, and same goes to the right side. Okay, and then I move everything from the right to the left. Okay, so the x square here, they will cancel off y square as well. And for the x value, I'm gonna move negative 12 to the other side, so positive 12 minus 4, that will be 8. And this negative 18, I move to the other side, it will be positive 18 minus 6, so it will be 12. And then here the 4 will be adding with 9, and then minus with 36, minus with 81, then you will get negative 104. Right? So as you can see now, these three values are actually even numbers, so meaning we can simplify them. So the value that we can simplify them would be dividing the whole equation with 4. Alright, with 4. Okay, so once we simplify, then this would be our equation. So again, which equation we are describing here? Which is this dotted line. Alright, so this dotted line, we have founded the equation, which is 2x plus 3y minus 26 equals to 0. For the next part, we need to find the equation of line AC, which is this line. Okay, so to find equations of the line, we need to have these two information: the gradient and the point which lies on the line. Right, so just now we have mentioned that line AC is actually parallel to line ED. Right, since these two lines are parallel, meaning their gradient is the same. Alright, so to find the gradient, we just need to find the gradient of line ED. And for second information is the point which lies on the line, so we are also quite lucky because it is already given. Alright, so now we know how to find the gradient and the point already. So let's start off with the gradient. Okay, so to find the gradient of line AC, we just need to find the gradient of line DE. Okay, so the formula, y1 minus y2, so let's say D is the first point, so 9 minus 3, and divide by the x coordinates, which is 6 minus 2, right? And we'll get the gradient is 3 over 2, and we have the points coordinates already, which is 4 and minus 4. So we are going to insert these three information into y equals to mx plus c. Okay, so we rearrange to find the value of c first, and then we can find our equation of the line, which is y equals to 3 over 2x minus 10. And for part C, it says hence find the coordinates of B. Alright, so realize here it says hence. Okay, why? Right, first things first, if you look at the diagram here, you can see that this point B actually lies on two lines. One is the line that we have found the equation just now, which is line AC, and the other one is the dotted line, which we have already found the equation in part A. Alright, so to find the coordinate of B, one of the things that we can do is we are going to insert one of the equations to the other. Right, because this point is the intersection point of these two lines. Right, that's why we can substitute one of the equations into the other. So the easiest way to do this is I would be inserting this equation into the part A equation. Okay, so it's easier because here the equation is already y equals to something. So I can just insert into here and change the value of y. Alright, and then here we'll be just simplifying, okay, and then find the value of x. So value of x here will be a bit weird. It will be 112 over 13, okay, and then we insert this value back to the equation in part B and find out the value of y, which is 38 over 13. But let's don't stop here, because here it says find the coordinates of B. We need to write these two answers that we have into the coordinate format, right? So you'll be writing this way, B bracket 112 divided by 13, comma 38 over 13 bracket. Next question coming from circular measure, and here we have some information given here, so let's go through it one by one. Alright, so here we have this circular park and the center is at O and its radius is 6. Alright, so here meaning it is 6 meters. And the next information is KOL is actually an arc of a circle centered at T. Right, so there's actually one circle which have the center T here. And the KOL, which is this line, is the arc. So if I extend this the line from K and from L, okay, you can see the circle even clearly. Right? So now if I draw to the center, which is this line is the radius. Okay, this line is the radius. And you can see that actually there is one part of the circle inside this circle. Okay? And the next information is AB is parallel to KL. So let me draw the arrows here to indicate it is parallel. And AB is equal to 6 meters. So let me put 6 here. So for part A, we need to find the angle of AOB, which is somewhere here. Right? So this is the angle that we need to find. And if we draw the lines, you can see that there is actually a triangle here. Alright? So if you see the marks given for this question, it only has one mark, which means this question will be quite straightforward. It's just that we need to find more information from this triangle. Alright? So, as you can see, line OA is actually the radius of the circle. Same goes to line OB, which is also the radius of the circle. So, both of the lengths are 6. And now if you see the length of all of these three lines, all of them are the same, which is 6. So this triangle is actually an equilateral triangle, right? Which means this triangle, their lengths and the angles are the same, right? So angles are the same, meaning these three angles are the same. So if we just want to find one of the angle, then the total angle in the triangle is 180, and if you want to find one of them, we just 180 divide by 3, which is 60. Alright? For the next part, we need to calculate the area behind the stage. Right? So it's not the main stage here, because here as you can see it's shaded. It's not this one, it's the area behind the stage. It's here. Okay, so to find area of shaded region, I will always recommend students to use either one of these two ways. Either big shape minus small shape, or add up all the shapes that we have. Right, so let me go through the first method first, which is big shape minus small shape. So let me use this into this question. Okay, so big shape is actually the shapes that I can recognize, and it includes the area that we are trying to find. So here, the shape I can recognize is this sector. Okay, this sector. So this would be my big shape. And how about the small shape? So small shape would be the shapes that I want to remove from the big shape, because I don't want it. So for example here, right, as you can see, this sector accidentally included the area here. Right? And as you can see, this is actually also a shape, which is the triangle, right? So from the big shape that I have, I need to minus off the parts that I don't want. which is this triangle, which is also my small shape. Okay, so if I minus the big shape with the small shape, then I can find the area that I want, which is this small part, right? Big shape minus small shape, then I can find the area that I want, which is below here. Okay, so how about the second method, add up all the shapes? So for example, we have this shape and we don't really recognize this shape, and there is no formula to help us to find this area. Okay, so what we can do is we can split it according to the shapes that we can recognize. So once I draw a line here, you can see that actually on top is a half circle and at the bottom is a rectangle. So we can use the formulas accordingly, and then we can add up the area of all the shapes that we have to find the area of the shaded region. Alright, so now coming back to here, the big shape minus small shape method, we are going to find the area behind the stage. Okay, so area behind the stage, it would be the big shape, which is the area of the sector, minus of the small shape, which is the area of the triangle. Alright, so how do we find the area of the sector? Where we can look at the formula sheet. So in formula 28, area of the sector is 1 over 2 r squared theta. So here we are going to put 1 over 2, and r here would be the radius of this sector or the circle, right, which is 6. Okay, I'm going to put a square here, and the theta. So theta here would be the area of the sector's angle, which is this one, right? Which we already found in part A, which is 60. Okay, but take note, yeah, for these two formulas, the theta, it must be in radians. Alright, so no choice. This degree, we need to change it into radians. Okay, so to do so, we can just 60 divided by 180 and multiply with 3.142, or is the value of pi. But please do not use pi in your calculator, please use 3.142. Okay, so once you get, you will have this answer, 1.0473. Make sure it is in 4 decimal places. Don't put 1, don't put 2, put 4. Because it can make your answer more accurate and less likely to be rejected by the SPM examiners. Alright, put 4 decimal places. Alright, so I'm going to multiply this value inside here, and let's find the area of triangle. So area of triangle, we can actually use one of the formulas in Form 4 Chapter 9, which is also in the formula sheet, formula 40. Okay, 1 over 2 AB sine C. So how to use this formula is, okay, let's say I use this triangle as an example. So if we have the lengths of two sides of the triangle, let's say it's OA and OB, and if we have the angle between the two lines, which is theta, then we can find the area of triangle. Right? So here it will be 1 over 2 multiplied with the length OA and the length OB, 6, and here the angle would be the angle between OA and OB, which is theta, which is also 60. Okay, so here we will be multiplying sine 60. Okay, notice here I put the degrees, it's not the radian. Alright, so except for formula 27 and 28, which uses radians, all of the other formulas which have angles, all will be using degrees. Okay, so that's why here I'll be using degrees. Okay, so take note, yeah, only formula 27 and 28, arc length and area of the sector, uses radians. Other than that, all use degrees. Okay, so now we have this already, then we can just plug this into calculator to find out the area behind the stage, which is 3.263 meters square. Alright, and there's one thing I like to let you all know for this question. So this question is actually quite tricky, because if you look at all the information given here, right, this one is not used. KOL is an arc of a circle centered at T. Right, so this I would say is like a trap to I would say confuse students. And also for part B as well, it says behind the stage, but actually they are shading the area at the main stage. So if you don't read the question clearly, you may be misdirected that you want to find the main stage area, not the area behind the stage. Okay, so for this kind of questions, we need to, I would say, more aware on what are the things that the question really needs to make us not be confused by all these extra information. Alright? And the last question for section A coming from functions. Alright, so here we have two kinds of functions. One is f of x equals to p minus 3x, and the other one is a composite function. So we have two functions here, g f x equals to x. So in part A, we need to figure out the value of p which is inside fx if this is given g of 2 equals to 5. So if you want to find the value of p, I think first thing first, we need to figure out the function g of x, right? Because in this information, it uses function g, but here it doesn't give us. Alright, so we need to figure out the function g of x first. Right, but before we find g of x, you can see this information is a bit weird, because if I put x into f and g, it will appear the same result. Okay, so this means if I draw out into a diagram, if this x is put into f and then it's put into g, you will get back the same value. So this is something similar that we have learned in this function also. So if x is put into f, and if I put into the f inverse, the inverse of f, we will get back the same value. So what does this say for g? So g is actually the inverse of f, because if you put f and then you put g again, you will get back the same value, which is why g is the inverse of f. Okay, so how do we write this into a sentence? Alright, so we can write it in this way. So this is something that we have learned. F inverse of f of x equals to x, and this is the information given in the question. So if we compare these two, then you can see that f inverse of x is equal to g of x, right? So to find g of x, we need to inverse this function, fx. Alright, so if we want to inverse a function, first thing first, we need to have these two equations. Alright, oops, sorry, let me erase this part. So we need to have two equations. So the first thing is y equals to f of x, which we see this all the time. Alright, and the second one is x equals to f inverse of y. So should we memorize this? Actually, no need. Okay, reason is because this second equation comes from the first equation. If we just move the f to the other side, so it will become f inverse of y. And on the right side, it will just be x. So if I just switch the places left and right, then I can get this equation already. Okay, so for the second equation, you don't need to memorize because it comes from here. We just need to move the f to the other side. Alright, so now let's inverse this function. But for a lot of students, I would say inversing a function might be hard because it involves a lot of steps. So what I'll be trying to do here is by applying this inversing function steps into real life application that we do all the time, which is washing clothes. Alright, so what do we mean by washing clothes? So let's assume that the function here is a dirty shirt. Alright, and this is a crucial point. Outside and inside of the shirt is dirty. Right? Two sides of the shirt are dirty, outside and inside. Okay, and since there are two sides, we need to have two soaps. So for the equations here, it will be represented by one soap. Okay, so now let's go through the steps. Right, the first step, if we want to clean this shirt, is to apply one of the soaps first, right? So let's choose the red soap and we clean outside of the shirt. Right, apply the first soap to clean outside of the shirt. So if we go to the function point of view, it will be applying this equation into the function here. So the f of x here will be changed to y. Right? We apply the first slope, or meaning we apply the first equation. And now you can see outside of the shirt is clean already. So now the second step to clean this shirt is to flip the shirt inside out, right? To access the inside of the shirt. So for the function, how are you going to do this? Well, we need to flip the left side of the equation from y to x, right? So meaning x should be on the left, everything else on the right side. Okay, so this involves a little bit of rearrangement here and there, and you can see that the x will be on the left, other things on the right. So now we have accessed the inside of the shirt already, so we apply the second slope. Okay, so this will be our third step, to apply the second slope to clean the inside of the shirt. So in the function point of view, it would be this equation substitute into this equation. So the x here will be changed to f inverse of y. Right? So now outside and inside of the shirt is clean already. Then our last step is to flip back the shirt. So for the function here, since just now we changed from y to x, now we change from y to x also. Okay? So here will be f inverse of x equals to p minus x over 3. Okay? And we have obtained our inverse function. But of course, just now we said that we need to find g of x, and g of x is the f inverse of x. So here we need to change it to g of x first, okay? Alright, so now we have the function g of x already, and we are given this information. So what we need to do is just to compare and find the values of the x and p, okay? So if you compare the things inside the bracket, we have 2 and x. So this means that x equals to 2. And also on the right side, we have 5 and p minus x over 3. So just now x was 2. So we're going to equate it together and to find the value of p, which is 17. For the next part, it says that we need to sketch the graph of f of x from 0 until 6. And then we need to use the horizontal line test to justify whether the inverse function of f of x exists. Right, so this one we have already done in part A actually. We have already proven that there is a inverse function of f. Okay, but now we need to use another way to prove it, which is using the horizontal line test. But how do we do that? Right, so let's recall back what is horizontal line test. So this test is to identify whether the function has an inverse function if the line intersects at one point only in the f of x graph. Right, so let's draw out that f of x graph first, and to see whether this line does it intersect at one point only. Okay, so let's draw out the graph. So we can use the range here. X start from 0 until 6. So when x equals to 0, which is the y-intercept, right? So we can find the y-intercept through here, because this is actually a line equation, right? Y equals to mx plus c. So we know that f of x is y, m of x is here, and c is here. So if we compare, the y-intercept, which is c, is equals to 17, alright? So our first point will be x equals to 0, y equals to 17, which is somewhere here. Then for the second point, we need to find the coordinate where x equals to 6. Alright, so let me plug this value of 6 into this function to find the y coordinate. Alright, which is -1. So we have another coordinate here, which is, okay, let me find my pointer. Okay, x equals to 6, y equals to -1. So if it's in this graph, the point will be here. Okay, so now I have the 2 points already, and I just join them to form the equation of the f of x. Alright, so now once we have drawn the graph, then we can use the horizontal line test. So I'm just going to draw one horizontal line here, and I'm going to move this line up, right? So for you can just place a ruler at the graph here, and then you move upwards, right? to see whether at any point does it intersect only one point. Alright, so as you can see, when we move up until the very end here, it only intersects one point. So this means that this function does have an inverse function, right? So let's write out all of the things that we have known inside our answer here. As the horizontal line test intersects fx at one point only, right? This one I think I cross off. The inverse function exists. Alright? So in your graph here, you can just draw a horizontal line here to let the examiner know that, oh, you have used this line test to prove that this function has an inverse function. You don't need to draw at every point of the line, okay? Otherwise, it'll be very messy for your graph. Alright? And another thing I think students will confuse is another line test in this chapter, which is called the vertical line test. Okay, so vertical lines are something like this, okay? So it has the same concept, it's just that it proves another thing, which is if it intersects one point, it will be a function, alright? Not an inverse function, but a function only. So for vertical lines, proves functions. For horizontal lines, prove inverse functions. Question 13, the first question in section B. So for section B, please make sure that you only do 2 of the questions that is required. Don't have to do all of them, alright? Because this paper is just 2 hours, it's not enough time for you to do all 3, alright? Instead, move the time to solve the questions that you have skipped or double check back your answers. Alright, so here we have 4 consecutive terms for a progression. Oops, sorry, this chapter is from progressions, right? So here we have 4 consecutive terms, which means these terms are back to back. Alright, so in part A, we need to state whether this sequence is a geometric or an arithmetic progression, and we need to justify, we need to prove. Alright, so let us recall back the things we have learned for geometric and the arithmetic progression. Okay, so one of the main properties, if we want to identify whether the progression is arithmetic or geometric, is to see what is the method to get the next number. If we need to add or minus to get the next number, then it's an arithmetic progression. If we need to multiply or divide to get the next number, it is geometric. So very simple example for arithmetic, it will be 2, 4, 6, 8, 10. As you can see, I'm adding 2 for each of the values, sorry, to get the next value. For geometric progression, it can be 2, 4, 8, 16, 32. As you can see, if I want to get the next number, I need to multiply something, which is 2. Alright, so coming back here, is this an arithmetic progression or a geometric progression? So here, as you can see, the power changes. So if we recall back, if we want to change the power of an unknown, alright, so let's say I put A here. So we need to multiply another value, let's say here MB, then we can add the powers. So for this case, if we want to go from M2 to M4, basically we need to multiply M2, right? Because 2 plus 2 equals to 4, which is the power, right? So now, as you can see, we multiplied a value to get the next number times M2. This proves that this is actually a geometric progression, alright? So now, how do we justify? How do we prove? Right, so we need to pull another property for geometric progression. So as you know, geometric progression uses R, alright? R, which is the common ratio. So to prove this, we need to extract or we need to calculate multiple values of R, okay? And if we can prove those values of R are the same, then it is a geometric progression, okay? So how do we calculate R? Very simple. Let's say we choose the first 2 terms. So to calculate the R, it would be this value divide with its previous value. Alright? The value divide with its previous value. So let's label this as the first R or R1, right? So m power of 4 divided by m power of 2, right? So we are dividing these two terms, so the power we need to minus, so this will be m2 or m squared, alright? And then we need to find another value of R in this progression. So this time, let's choose these two terms, right? So again, this value divide with its previous value. So this I can label it as the second R or R2, and here will be m power of 6 divided by m power of 4, and I divide meaning minus the powers, then I can get m squared. Alright, so we have proven that the value of R is the same, so this means that this is a geometric progression, and then we create out this sentence. Okay, since R1 equals to R2 is a geometric progression. So how about arithmetic progression? If let's say we found out that this progression is an arithmetic progression and we need to justify. Okay, this one we need to use D. Alright, D. So same thing as well actually. To find the value of D, it would be, let's say I choose this value, I minus with its previous value. So let's say this is the first D, so 4 minus 2 equals to 2. And let's find another D, okay, D2. So here let me choose these two values, and let's say 6, I minus its previous value. So 6 minus 4, which is 2. So since we have proven that the two values of D are the same, then it will be same thing here as well. It's just that here will be, since D1 equals to D2, it is a arithmetic progression. For the next part is actually a unique question, so let's go through this sentence by sentence, alright? So in 2025, there are two factories which named A and B, so these are the tons of palm oil they produce, right? But because there are other palm oil mills nearby, so meaning more factories are sharing the same resources, so for factory A and factory B, their production will reduce year by year, alright? So they have calculated the decrease, and it follows a geometric progression, right? So means we need to use geometric progression for this case, alright? And it says that the tons of oil in factory A decreased 12% year on year, and factory B decreases 9% year on year. Okay, so now it asks us in which year, right? Which year does the production in factory A less than the production in factory B for the first time? Alright, so in this situation, should we use Tn or Sn? Right, so if you read back this sentence again, in which year the production of factory A less than B for the first time? So it's just looking at for every year, I compare the production of A and B to see which one factory A is less than B for the first time. So it's comparing year on year. So for example, I compare 2025 once, I compare 2026 once, I compare 2027 once. It's not like I compare the total 3 years and then I compare the total 3 years to see which one is the first time A is less than B. It only focuses on that year itself. So there is no total involved here. That's why the Sn here, we are not going to use it, we are going to use for Tn. Okay, so from this situation here, this sentence here, let's write out an inequality. Okay, because here it is less than. Alright, so if we want to find out the production of palm oil for factory A, so let's denote it as Tn and then put the A on top. And for factory B, it will be the same thing as well, Tn and then put B on top. Right, so this will be our inequality. Okay, and now what we need to do is for factory A and factory B, we need to figure out the value of A and R. So A here represents the first term, so in our situation here would be the production of oil in the first year. So since this situation starts in 2025, so I'm going to assume that this year is the first year, so the 5200 here would be the projection for the first year for factory A. So here I'm going to denote it as A and then a big A here. Alright, and for R is the common ratio. So this common ratio would be the percentage of amount that would be produced for the next year based on the previous year. Okay, so can we use 12% as R? Actually cannot, because this 12% is representing the decreased amount year to year. It's not the amount that we can produce for the next year, right? So if you want to figure out the amount that we can produce for the next year, what we do is just very simple. It's just 1 minus the decreased percentage, right? And then you will get the percentage that it will be produced for the next year, right? So here will be 0.88 or 88%. So this will apply the same thing for factory B as well. So for the first term or A, it will be 4500, and for the common ratio here, it would be 1 minus 9% or 0.09 to get 0.91. So if you compare the values here, right, you can clearly see that there will be years where factory A is less than factory B. Okay, so if you compare the value of A, of course factory A has a higher value than B. But if you look at the value of R, right, factory A is much lesser compared to B. So this means that for every year goes by, factory A value would be going down faster compared to factory B, because the value of R is higher. So now we just need to find in which year does this pattern start, where factory A is less than B. Okay, so now let's use our information here and to substitute into this inequality here. Okay, oh sorry, let me remove this a bit. Alright, so for A, we are going to substitute according to the formula here. So A will be 5200, R will be 0.88, and there will be a power n minus 1 here. And on the right side, same thing as well, 4500, and the R here will be 0.91 with the power n minus 1. Okay, so now for the things which have n, I'm going to move it to the left side, and those which don't have n, move to the right side. Okay, and you can see that the power here, both of them have the same value, so actually we can combine these two to become something like this. And for the right side, I'm going to cross off the zeros, so it will be 45 over 52 here to simplify things. Alright, so now we need to find the value of n, but the n is at the power part. So how are we going to move this n minus 1 to here? So it's one of the things that we have learned in the previous questions, which is we are going to apply log for both sides. Right, so just for information, ln is actually the short form for log 10. Okay, and this is accepted in the SPM lah, so don't have to worry. Alright, so if we apply log for both sides, then this n minus 1, it can appear on the left side of the log. Alright, so now if you want to find the value of n, you just move this part of the value here to the other side. Okay, but this value, if you put into a calculator, you will realize that it is a negative value. Alright, so recall back, for values in log, if let's say it is greater than 1, it will be a positive value. If the log value is equal to 1, it will be 0. If it's between 0 to 1, then this is a negative value. So if you see, if I divide these two values, the value below is greater than the value above, so it would be lesser than 1 already. So this value is actually negative. So if we move negative value to the other side, then we need to change the sign from less than to greater than. Okay, so this I would say is like a trap for students. So please make sure if you see values which are quite small, which is especially lesser than 1, you can type this in the calculator to see whether it's negative or not. Alright, so this one, please take note, yeah? Okay, otherwise it will change your conclusion for the... It will change your conclusion when you get the answer. Alright, so now once we change the sign already, let's calculate this into a calculator. Alright, and then we move the -1 to the other side, so it will be 5.312. But n is an integer, so we need to find out the smallest integer which is greater than this value. So it will be n equals to 6. And oh sorry, there is one error here. This should be 5. Okay, this should be 5. Right, so n equals to 6. So which year is n equals to 6? So this one we can calculate it through this way. So we know that 2025 is the first year. Right, so now we need to find T6. Okay, so very simple. We just add 5 to get T6, right? 1 plus 5, 6. So for the year, same thing as well. We are going to plus 5. So this would be 2030. Okay, so the answer would be year 2030. It's not the answer in the answer scheme, alright? So if you see the answer scheme is 2031. So I think they just added 2025 with 6 straight away. But it's incorrect, yeah. It should be using this way to figure out the year, right? So I can show you all. Right, so if I list down all the years here, you can see that for n equals to 6, T6 is 2030, right? 2031 is T7, so we are 1 year ahead already. Okay, so again, answer is 2030. For the next question, it says that differentiation method is not accepted, so no choice, we cannot use the differentiation method. So the other thing that we see that there is this quadratic function here. So this question actually comes from the quadratic function chapter, alright? So before we go to part A, let's understand this function first, right? So we have this annual profit function called u of x, okay? So this function calculates the profit. And notice that it is in millions, okay? So this x represents the selling price of the product and it's thousands of million ringgit. So please take note, yeah, the units here are different. U of x is millions, x is thousands. Alright, so now in part A, it tells us to find the range of the selling prices to avoid incurring losses. Okay, so how do we apply the things that we have learned in that chapter to here? Okay, so let's help us to translate the selling price and the avoid incurring losses in terms of the function here. Alright, so selling price is what? Selling price is actually the x, right? So I'm going to put x here. And avoid incurring losses. Okay, avoid incurring losses means that there would be profit or it can break even, right? Okay, so profit meaning the revenue, it's more than the cost, right? So break even is actually revenue equals to the cost, so means there's no losses. Okay, no losses. So since this one involves the profit, which is u of x, okay, so meaning this value cannot be less than 0, right? Because less than 0 would be loss, right? Loss is less than 0, break even is equal to 0, profit is greater than 0. So to avoid those loss, it would be these two conditions combined together, which would be greater than or equal to 0. Alright, so now we have translated this sentence into the things that we have learned, right? So we want to find the value of x, where u of x is greater than or equal to 0. Okay, so this is one of the techniques that we need to, I would say, adapt ourselves to transform these sentences to things that we have learned. Okay, so we translate it word by word. Selling price. What is selling price? X. Avoid incurring losses. So losses, profits, or break even involves u of x. That's why I'm going to use u of x, and then I need to see whether this u of x satisfies which condition: profit, break even, or loss. So since we are avoiding loss, then we just consider greater or equal to 0. That's why we can obtain u of x greater than or equal to 0. Alright, so now we have this inequality, so let's figure out the value of x, right? So if you notice this sentence also, it says range. So if you see range, actually the answer, you will see that there are inequalities. Okay? So now to find the x here, so we are going to substitute the function inside here. Alright? But in here, if you see the x square value is negative. So what we need to do is we need to change this to positive to ensure, because if let's say it's negative, there will be some other things that we need to do to take care of the negative. So to prevent all that, why not we change from negative to positive, right? So to do so, we can multiply the entire equation with -1. Alright? And another thing is, as you can see, these three values, they are all even numbers. So meaning we can further simplify them and we can divide it with 2. Alright? So for all of the values here, you multiply and divide by 2, you will get something like this. Alright? And how about the right side? So since we have multiplied negative to entire equation, means that this sign we need to change from greater than and equal to, we need to change to lesser than or equal to 0. Alright, so now we have a quadratic inequality. Now we can use the factorization and insert this into calculator to find out the value of the two x value answers, right? Which is 6 and 2. And since this is a quadratic inequality, we need to use another way to find out the answer. So we are going to use this graph method. Okay, this is known as the graph method. So with the two x values that we have found just now, and this is actually the x-axis, so now we are looking at the values which have lesser or equal to 0. So we are going to look at the region below the x-axis. Alright, so this would be our range of values of x. Right, so our answer would be x is between 2 to 6. So if we want to translate this one back to selling prices, take a look, yeah, selling prices is in thousands of Malaysian ringgit. So what we are going to do is the annual selling prices are between 2,000 and 6,000. But before we go into part B, I would like to explain another method which solves the quadratic inequality, right? Which is called the number line method. So what I noticed is for the questions in other states, for example Malacca, Perak and Terengganu, they force students to use this method to solve the quadratic inequalities. So it's like, with this inequality, please solve using the number line method, which I'm not sure why, but it can be a sign that it will appear in SPM, we're not sure. But to safeguard ourselves, of course, we need to learn how to use the number line method. So I'll be using this opportunity to use this question and using this number line method. Alright, so let's assume that we are still at this stage. Okay, and then we need to find out we need to solve this quadratic inequality. Right, so we have just found out the value of the x, so it will be 2 and 6, right? So for the number line method, we need to split all the values into 3 parts. Okay, so the first part is all the values that are lesser than 2. Alright, the second part is the values between 2 and 6. The third part is the values that it is greater than 6. Right, so this number line will be separated into 3 parts. Okay, and this would be the ranges that we will be setting. Right, and you'll notice that the inequalities here, all of them have the equal sign, right? Because we need to follow here. If there's an equal sign here, then all of it have to follow. Right, so this means that here I also need to put the equal sign. Okay, so with these 3 parts, what we need to do is, if we substitute the values in each of the parts, what would be the result? Would it be positive or negative? Okay, so the number line method is quite straightforward. From all the values, we separate it into 3 parts and we see for each of the part is it positive or negative. It is satisfying the condition which is negative for our case, then that range would be our answer. Alright, so let's go through part by part. Alright, so for the first part, let's choose x equals to 1. Alright, so for the x value, I'm going to substitute it here. Alright, so it would be 1 minus 6 and 1 minus 2. But here I don't need to find the value, I just need to know whether it's positive or negative. So 1 minus 6 is a negative value, 1 minus 2 is negative value, so negative, negative, positive, right? So here will be positive value. And let's go to the second part. Let's say for this range, I choose x equals to 4. Alright, so 4 minus 6 multiply 4 minus 2. So the first value here is a negative value. The second value is a positive value. So negative, positive, negative. Alright, so this will be a negative value. And for the last part, let's say here is x equals to 7. So 7 minus 6 and 7 minus 2. So here would be a positive value multiplied with a positive value. So here is positive. Alright, so now we are going to identify which parts are negative. Alright, which is this part in the middle. So this would be our answer. X is between 2 to 6. The same answer that we have gotten in graph method. Next part, it says find the optimal selling price and the expected maximum annual profit obtained by the company. Alright, so let's translate word by word. So selling price again is x, and annual profit is u of x. Maximum, okay, how do we find the maximum? So according to our chapter here, if we want to find maximum or minimum of something, we need to find out the maximum point or the minimum point, right? So how do we find the maximum point or the minimum point? Which is through a version of the quadratic function, which is called the vertex form. Remember the vertex form? So h of x equals to ax minus h squared plus k. So the minimum or the maximum point is hk, right? From these two values. So what we need to do to find the maximum or minimum point of something, we need to figure out the vertex form of this function first. Alright, so how do we change this function to be the vertex form? Is through completing the square. Alright, so completing the square, we just need to use these 3 steps, which I'm going to let you all know step by step. Alright, so the first step is to factorize. Right, so what do we mean by factorize? For factorize meaning, from the values that have x, which is these two, I'm going to factorize the value negative 2, which is the value of x squared. Okay, so means I need to take out negative 2 from these two values. Right? So if I take the negative 2 out, it will be something like this. Right? So negative 2 will divide with negative 2 to have 1 here, and 16 will divide with negative 2 to get negative 8. Alright, the value on the outside, we don't need to do anything, so we just remain. Alright, so this is the first step. Factorize using the value of x squared. So the next step is to divide and square. So the things in here are going to remain the same. It's just that inside the bracket, we are going to add 2 values. Right? So the first value is from the value of x, which is negative 8, I'm going to add it, and I'm going to divide by 2 and square it. Alright, so divide by 2 and square. So since we added this value, then at the back we are going to minus the exact same value. right? So why we minus is because we want to make the equation balance, right? We cannot just add one thing and then not do the other thing, which is to minus. Alright, so this would be our second step. And now the third step is to combine. So what we mean by combine is we are going to combine the values. Sorry, we are going to combine the first three values that has square, which is x, and negative 8 over 2, which is negative 4. Right, so for the next part, here in the bracket, it will be x minus 4 bracket square. Okay, and for the value at the back, this is just simplifying. Okay, so negative 8 divided by 2 is negative 4, negative 4 square is 16, and 16 have a negative outside, so here will be negative 16. Okay, so this will be the three main steps to complete the square. So for the steps here, moving forward, it's just manipulate. Alright, so here what we're going to do is for the negative 2, I'm going to multiply into these two values. Alright, so here will be negative 2 x minus 4 square, and 16 here multiply with negative 2, so here will be positive 32, and don't forget the value at the back, negative 24, and I simplify the values at the back, it would be 8. Right, so now you can see that this is actually the vertex form. Alright, and if we compare the forms here, you will see that the... Okay, so is this minimum point or maximum point? Negative 2 here is the value a, right? So as we know, value of a, if it's greater than 0, it is the minimum point. If the value of a is lesser than 0, then it is a maximum point. So this is the maximum point, and if we compare, we can find out the coordinates of the maximum point, which is 4, which is the h here, and 8, which is the k here. Alright, so since 4 is the x value, so we know that x, according to this question, is the selling price, optimal selling price, and it's in thousands, so the optimal selling price is 4,000. And for the 8 here is the y coordinate, or in this example, in this question, is ux. So ux is based on millions of Malaysian ringgit, so the expected maximum annual profit is 8 million. Alright, so please make sure the units are correct, because here it says that the units are different. Ux is in millions, x is in thousands. And the last question of this paper we have from vectors. Right, so there's a few information here, so let's go through one by one and I'll explain it in this diagram here. Alright, so the first information that we have is this one, okay, this ratio. So it tells us the ratio of this line ABP. So what I'll usually do is, for all the unknowns, I'm going to move it to the right side first. So meaning BP would be at the bottom of AB. Alright, and since here is a fraction already, so on the right side it only left with 2, but I want this to become a fraction, so very easy, I just put over 1 here. Alright, 1 as the denominator. So why I do this is because I can easily compare the ratio already. So meaning AB is 2 parts, BP is 1 part. Alright, as you can see here. So this helps us to identify the ratio in the lines. Sorry, in the line. Alright, so now let's go through the information here. So the first vector that we have is OA, which is 4x. So as you can see here in this sentence, yeah, this one, rectangle OABC. So means that if OA is 4x, means the line here CB is also 4x. Alright, because it's a rectangle, meaning CB and OA, they are parallel. Alright, so same goes to the other vector as well. OC is 4y. So means that since this is a rectangle, OC and AB have the same vector. Okay, because it's a rectangle and because they are parallel. Alright, And also OS here, it's somewhere here. So we have also given the vector, and also the last thing is OR and RA are equal to each other, which means the distance from OR and RA is the same. So meaning R is the midpoint of the line lah. Alright. So you will be asking, why did I highlight all the lines that has vectors? Okay, reason is because for the next few questions, we need to find other vectors. So the easiest way to find other vectors is to calculate it through lines that has vectors already. Right? Because we can easily differentiate those lines which don't have vectors, and we can exclude them for our calculation. So we can save more time. Right? So before we go to part A, there's another thing I'd like to let you all know, which is this line BP. Okay, this line BP, it has the ratio, but it does not have the vector. So I'm going to put it as grey color. So this actually, we can find the vector, it's just that we need to find the vector of AB first, then only we can calculate what is the vector of BP. So it's technically an indirect way to find the vector. We first need to find AB. Okay, so in part A, we need to find the vectors of RS and OP. So for this kind of questions, we need to remember this step, which is always to find the route first. Okay, so for example, RS. So how are we going from R to S? Right? We need to set our route. We need to set our journey. So one of the ways to go from R to S would be passing through O. So it would be from R to O and then O to S. Right? So we can write it here. From R to O and then O to S. So this one is very important to obtain your marks, alright? Because this one, 99% of the time, you will be granted 1 mark. And 1 mark is also very important in maths, right? So yeah, we need to set our route first. Okay, so once we set our route, then we can find the value of these two vectors lah. Okay, so RO is this line, and we are going to the left. But if you look at the vector given here, which is 4x, it's actually going to the right side. So since we are going in two opposite directions, so we need to put negative. Alright, negative represents opposite direction, because R to O is going to the left, O to A, which is the 4x, is going to the right side. So we need to put negative. Okay, negative OA, opposite direction of OA. And also, if you notice, RO is actually half of the line OA, so here we need to multiply half, right, or divide 2. And for OS here is quite straightforward, is 3x plus 3y, which is already given, but here I wouldn't write 3x 3y in the same sentence here. Okay, as you can see, there are two versions of vector already. One is this one, and the other one is this. So in writing out vectors, for each line, it cannot have two different forms of vectors. Okay, so this is considered one form, this is considered another form. We need to standardize, right? Make sure every line has only one form of vector. So for this line, I'm not going to write out 3x plus 3y. We are going to remain it the same, plus OS. Then only the next line, I change everything to that form. Okay, so OA here is 4 of x, so I'm going to put 4 of x here, and OS would be 3x plus 3y. And then I simplify this, then I can get the answer. Alright, so you can see from the second line to the third line, each of the lines only have one form of vector. Right, so please make sure you do this during SPM lah. Right, and for the second vector that we need to find is OP. Right, so OP, let's find out the route first. So let me use another pen color. Alright, so from O to P, I think the fastest way to do this is from O, I straight go to A, and then A, I straight go up to P, right? So this would be our route, OA and then AP. So OA, to find the vector of OA, we already found it, which is 4x. Okay, but wait, let's see AP, is it given already? So the answer is no, because this part, again, it's gray color. Right, so OA, I'm going to remain as OA first, and let's figure out AP. So how do we find the vector AP? Well, we need to depend on the part where it has the vector, which is this part AB. So AB, we know that it is 4y. And for AP, it's actually 3 parts. Okay, so since we know that 2 parts equals to 4y, how about 3 parts? So to find 3 parts, very simple. It's just 4y, we are going to divide with 2. Okay, and then I can find out the vector for one part, which is 4 divided by 2, 2y. And then to find 3 parts, then I just multiply with 3. It will be 6y. Right? So notice what I did here. So to find the vector with 3 parts, it would be divide by 2 first and then multiply 3. Okay, so I will be writing it here. I will divide 2, multiply 3 by using what vector? The vector which is given here, vector AB. Alright, so now with all of the vectors that we know the value of, then we can just substitute it here. So OA would be 4x, AB would be 4y, and I simplify, then I can get the answer, which is 4x plus 6y. Alright, next part, we need to find the ratio of m and n, which is actually the ratio of OS and OB. So all of these points are actually on the same straight line. So this means we can use one of the main properties in vectors, which is called parallel or collinear. So this means that if one vector can be obtained by multiplying a value with another vector, then these two vectors would be parallel or collinear. So what is collinear? Right, so let's go to parallel first. So parallel, we know that it is two lines which have the same shape, right? Collinear is actually just combining the two parallel lines to form one straight line. Okay, and in the straight line, there will be 3 points, and those 3 points are on the same straight line. So inside them, there are 2 parallel lines. Right, so this is called collinear. So if you look at our situation here, OSB, they are actually the same thing as well. 2 lines, and they are on the same straight line, and there are 3 points. Right, so this means the vectors inside this line would be collinear within each other. So collinear vectors can be OS, SB, or can be the whole line OB. Alright, so here OS and OB, this line and OB, which is this line, they are on the same straight line, hence they are collinear also. Right, so to find the ratio here, what we can do is we are going to use this equation and we plug the vectors that we want and to find the lambda value. Okay, so this is called lambda, L-A-M-B-D-A. Right, so for AB, I'm going to substitute with OS, CD, I'm going to substitute with OB. Right, so let's find out the vectors of OS and OB. Okay, so OS here, we have already found, sorry, it's not found, it's given, which is 3x plus 3y. But how about OB? Okay, OB, I think we need to calculate a bit. Right, so let's remain OS first. So OB here, from here to here, okay, quite straightforward, I think. So O to A, and then A to B, right? So OB here would be O to A, and then A to B, right? And O to A, we have the vector already, which is 4x, and AB is 4y, right? So we can just substitute the values that we know of, and then I'm going to multiply this lambda into the bracket here. Okay, so now to find the lambda value, what we can do is to compare the values which have the same vector. So meaning 3x here, I'm going to compare with 4 lambda x to find the lambda value. Alright, so 4 move to the other side, so lambda is 3 over 4. Alright, so how do I transform this 3 over 4 to ratio? Okay, that's the question. So for the lambda value, let us go back to this one. Okay, let's change this equation in a way that lambda will be on the left, the rest of things to the right side. Okay, so once we've done that, you can see that lambda is actually equals to OS divided by OB. And if we equate these two things together, we will get something like this. So now you can clearly see the ratio already, right? OS is 3 parts, OB is 4 parts. Okay, so let's rewrite this thing into this format. Alright, so OS OB, it will be 3 to 4. And since the question tells us to find the ratio of MN, so no choice, for the OS and OB, we need to change to MN. Okay, so MN equals to 3 to 4, and this will be our answer. Alright, the last part, we need to prove that the building RSP, which is this, and this, are on the same straight line. Okay, so means we need to prove that they are actually on the same straight line, something like that. Alright, so how do we prove 3 points are on the same straight line? Actually, we can use back the property that we did in part B, which is the parallel and collinear equation. Okay, so collinear again is 2 parallel lines combined together to form one line, and there will be 3 points on that line, 2 vectors here. Or I can have another vector which is the entire line. Okay, so here, in order to prove these 3 points are on the same straight line, we need to prove these 2 vectors must be parallel or collinear. So we need to plug in the vectors in this line into here. Okay, so we need to find any 2 vectors which involves the points R, S, and P. So if you go back to part A, we already have one, RS. It's in part A1, and we have found out that this vector is x plus 3y. Okay, so we need to find another one. So since we don't have the vector for SB, so let's not use another vector with using the point S. Alright, so what about we try to find this one, the vector from R to P. Okay, because as you can see, the entire route is highlighted. Alright, so we can find the vector of RP. Alright, so now we have these 2 vectors, and now we need to prove it that it is parallel. Alright, so we are going to put RS and RP inside here. Okay, but what is the result that we are expecting? Okay, let's go back to part B. Let me show you something. Okay, sorry, I need to scroll a bit. Okay, this part. So just now, we have proven that lambda is 3 over 4, right? But we just use the x value only. We ignored the y value. So actually, we need to do it, but it's just that if we use the y values, right? If you compare the value, it will be the same value. Lambda equals 3 over 4. Okay, so this means if both of the lambda values are the same, means that these 2 lines are actually parallel or collinear. Okay, if the 2 lambda values are the same, means it is parallel or collinear. If it's not the same, means it is not parallel and not collinear already, which means the buildings R, S, and P are not on the same straight line. Okay, so the result that we should be expecting here is we find the value of lambda from x, and we find the lambda value from y. If both of them are the same, meaning the vectors here are parallel, meaning these three buildings are on the same straight line. Okay, so now let's find the vectors first. So RS we already have is just RP. Okay, RP we need to find the route first. So from R, let's say we go to A and then we go straight up to P. Okay, so that will be our route. So now for each of the vectors, let's see if we can find the value or not. So RS we already have, which is one. okay, RA we need to calculate a bit. So RA is actually half of this line, so for X we need to divide by 2. Alright, which means OA we need to divide by 2. And here we don't need to put a negative because RA has the same direction of OA. All of them are going to the right side. So for this time, there is no negative here. Okay, so once we have the vectors ready, the value of the vectors ready, then we can just substitute inside. So x plus 3y, OA here will be 4 of x, so divide with 2 will become 2x, and AP is 6y. Oh, yeah, because in part B, let me go back to part B a bit. Okay, part B, just now we have, part A2. So just now for AP, we have already found the value, which is 6y here. Okay, so that's why in here, we can just change it to 6y. Alright, so we multiply the lambda value inside. Alright, so now let's compare the values of, compare the values with vector x, compare the values with vector y. Okay, so here will be 1 equals to 2 lambda. So if we find out the lambda value, it's 1 over 2. And for the values which have y vector, same thing as well. We get lambda is 1 over 2. So since both lambda values are the same, which means R, S, P are on the same straight line. Alright, so that concludes the discussion of this paper. Hopefully you have learned lots of it. So if you have any questions regarding this discussion, feel free to put your questions in the comment section below. I will try my best to reply as soon as possible. Alright, and for the next question, next paper that I'll be doing would be Kedah paper 2. Hopefully that will come out around 1 to 2 weeks if I have the sufficient time. Alright. And also another thing, because now it's already past the trial paper and now it's SPM is coming up, so of course don't pressure yourself too much, right? So make sure to take care of yourself because health is important. It's more important than anything else. Alright, so I'll see you in the next video. Take care of yourself and have a nice day, and I'll see you in the next video. Bye bye.